There is a photograph of Edwin Hubble at the eyepiece of the Great Hooker telescope, his face turned toward the dark, and in that stillness one senses a man who understood that patience, true patience, could remake the entire universe. He was a lawyer before he was an astronomer, a Rhodes scholar who might have argued cases in courtrooms but instead chose to spend his nights alone on a cold mountaintop, measuring the faint light of galaxies no one yet believed existed beyond our own. If these quiet evenings help settle the mind, a subscription ensures more such hours will find their way to you, whenever rest feels far. The air on Mount Wilson carried the scent of pine and distance, and Hubble would arrive at the observatory as the last daylight faded, ready to begin his slow and patient work, and so his story opens here. On the 20th day of November, in the year 1889, in a modest wooden house in the small town of Marshfield, Missouri, a boy was born who would one day change the way humanity understood its place in the cosmos, though of course no one present at that birth could have imagined such a thing, and the day itself passed much as any other late autumn day in that quiet corner of the Ozarks, with the last of the leaves clinging to the oak trees and the wood smoke rising from chimneys. Throughout the town, and the usual business of daily life continuing without any particular notice that something of future consequence had occurred. The child was named Edwin Powell Hubble, and he entered a world that was, in many ways, still quite small and knowable, a world of horse-drawn wagons and oil lamps and letters that took days or weeks to arrive, a world in which the town of Marshfield itself numbered fewer than 2,000 souls, most of whom knew one another by name and by family history and by the ordinary connections that bind together people who share the same streets and churches and general stores across the span of years and generations. His father was John Powell Hubble, a man of serious disposition and considerable ambition who worked in the insurance business, a profession that required a careful mind for numbers and risk and the patient accumulation of modest gains over time, and his mother was Virginia Lee James Hubble, a woman of gentle temperament and deep religious conviction who managed the household with the steady competence that was expected of wives and mothers in that era, and who would eventually bear 8 children in total, of whom Edwin was the third, arriving after his older siblings Henry and Lucy and before the younger children who would follow in the years to come, those being William and Helen and Emma and Elizabeth and finally John, the youngest, so that the household was one of considerable size and constant activity, filled with the sounds of children playing and quarreling and growing up together in the manner of large families everywhere. Marshfield in those days was a town of wide dirt streets and wooden storefronts and a central square where farmers from the surrounding countryside would come to trade their goods and exchange their news, and the pace of life there was measured by the seasons and by the rhythms of agriculture that had shaped the region for generations, and there was a certain quietness to the place, a sense of being somewhat removed from the larger currents of American life that were transforming the cities of the East and the industrial centers of the Midwest, and yet it was not an isolated place either, for the railroad passed through and brought with it newspapers and visitors and the occasional glimpse of a wider world beyond the rolling hills and the cultivated fields that surrounded the town on every side. The Hubble family occupied a comfortable position within this community, neither wealthy nor poor but possessed of that moderate prosperity that allowed for a decent home and adequate food and the expectation that the children would receive proper educations and grow up to lead respectable lives, and there was a strong Protestant faith that ran through the household, a faith that expressed itself in regular church attendance and daily prayers and a general moral seriousness that shaped the upbringing of all the children, including young Edwin, who absorbed these values in the way that children do, without necessarily questioning them but simply accepting them as the natural order of things, the way the world was supposed to be. Edwin's grandfather on his father's side was a man named Martin Hubble, who had spent his life as a farmer working the Missouri soil, and who had accumulated through years of patient labor not only a modest farm but also a certain store of practical wisdom and a curiosity about the natural world that perhaps set him apart from some of his neighbors, for Martin Hubble was a man who liked to understand how things worked, whether it was the growth of crops or the behavior of animals or the movements of the stars overhead, and this curiosity, this willingness to look carefully at the world and wonder about it, was a trait that would prove to be of considerable importance in the life of his grandson, though of course neither of them could have known that at the time. There is a story, passed down through the family and repeated in various accounts of Edwin Hubble's early life, that when the boy turned 8 years old, his grandfather Martin presented him with a gift that would prove to be formative, a small telescope through which the child could observe the night sky, and whether this story is entirely accurate in all its details or has been somewhat embellished in the retelling, as family stories often are, there does seem to have been some early exposure to astronomical observation that captured young Edwin's imagination and planted a seed that would eventually grow into something much larger, and one can picture the boy, perhaps on a clear Missouri evening in November of 1897, putting his eye to the eyepiece of that modest instrument and seeing for the first time the craters of the moon in sharp relief, or the bright point of Jupiter attended by its tiny moons, or the countless stars of the Milky Way resolved into individual points of light where before there had been only a hazy glow, and feeling that particular sense of wonder and curiosity that such sights can inspire in a young mind. The night sky over Marshfield in those years would have been remarkably dark by modern standards, for there was no electric lighting to speak of, and the town was small, and once the oil lamps were extinguished and the fires banked for the night, the darkness was deep and complete, and the stars emerged in their full glory, thousands upon thousands of them visible to the naked eye, the great arch of the Milky Way stretching from horizon to horizon like a river of light, and the planets moving slowly against this fixed background in their ancient and predictable patterns, and all of this would have been available to any child who simply looked up, though not every child who looked up would grow up to revolutionize our understanding of what those distant lights actually were. The family's life in Marshfield continued for the first few years of Edwin's childhood, and he grew in the usual way, learning to walk and talk and read and write, playing with his siblings and exploring the town and the countryside around it, attending school and church and absorbing the lessons that were offered to him, and by all accounts he was a bright child, quick to learn and curious about many things, though there was nothing particularly unusual about him that would have marked him out for future greatness, no obvious signs of genius or exceptional ability, just a boy growing up in a small town in Missouri in the last decade of the 19th century, much like countless other boys in countless other small towns across America. Among the influences that shaped young Edwin's imagination during these early years, there were the books that he encountered, and particularly the science fiction novels of Jules Verne, that French author who had captured the imaginations of readers around the world with his tales of extraordinary voyages and scientific adventures, stories of journeys to the center of the earth and voyages beneath the sea and trips around the world in 80 days and, perhaps most significantly for young Edwin, journeys to the moon and beyond, and these books, which the boy read with great enthusiasm, opened up possibilities in his mind, suggested that the universe was a vast and wonderful place full of mysteries waiting to be explored and understood, and that human beings, through the application of science and ingenuity, might one day reach out and touch those distant worlds that had seemed so unreachable to previous generations. The Verne novels were not, of course, scientifically accurate in any rigorous sense, being works of imagination rather than technical manuals, but they conveyed a spirit of adventure and discovery that was perhaps more important than mere accuracy, a sense that the boundaries of human knowledge were not fixed but could be pushed outward through courage and determination and careful thought, and this spirit seemed to resonate with something in young Edwin's character, some inclination toward exploration and understanding that would eventually find its expression not in fantastic voyages of the sort Verne described, but in patient observations made through telescopes and careful measurements recorded in notebooks and the slow accumulation of evidence that would ultimately reshape humanity's conception of the cosmos. In 1893, when Edwin was just 3 years old, the family's circumstances changed in a significant way, for his father John accepted a position with an insurance firm in the Chicago area, and the Hubbles packed up their belongings and left Marshfield behind, moving northward to the great city by the lake, where the opportunities for advancement in the insurance business were considerably greater than they had been in rural Missouri, and where the family would make their home for the years that followed, years during which Edwin would grow from a small child into a young man and would begin to develop the interests and abilities that would eventually lead him toward his life's work. The move from Marshfield to the Chicago area was a significant transition, for Chicago in the 1890s was a city of enormous energy and rapid growth, a city that had risen from the ashes of the Great Fire just 2 decades earlier and had transformed itself into one of the largest and most dynamic urban centers in America, a place of towering buildings and bustling streets and immigrants from every corner of Europe and industry and commerce and culture all mixed together in a great, churning mass of humanity, and this was quite a different environment from the quiet streets of Marshfield, with its population of fewer than 2,000 and its leisurely pace of life and its intimate familiarity with every neighbor and shopkeeper. For a young child, such a move would have been disorienting and exciting in equal measure, for there would have been so much that was new and strange, the noise and crowding of the city, the unfamiliar faces, the different rhythms of urban life, and yet children are adaptable creatures. And Edwin seems to have adjusted to his new surroundings in the way that children do, making new friends and finding new places to explore and continuing the business of growing up that had begun in Missouri and would continue now in Illinois. The family settled in the suburbs rather than in the city proper, in communities that offered something of a middle ground between the rural life they had left behind and the urban intensity of Chicago itself, and this suburban environment provided a reasonably comfortable setting for raising a large family, with yards for the children to play in and schools for them to attend and churches where they could continue the religious observances that had been so important to the household in Marshfield, and John Hubble's position with the insurance firm provided a steady income that allowed the family to maintain their moderate prosperity even as the children continued to arrive and the household grew ever larger. Edwin's early reading habits, which had begun in Marshfield with the Verne novels and other books that captured his imagination, continued and developed during these years in the Chicago area, for he was a child who loved to read and who found in books a doorway to worlds and ideas that extended far beyond the boundaries of his immediate experience, and this love of reading would serve him well in the years to come, for the life of a scientist requires a great deal of reading and study, a willingness to engage with the accumulated knowledge of previous generations and to build upon what others have learned and discovered, and the habits of mind that Edwin developed during these childhood years, the patience and curiosity and love of learning, were all qualities that would prove essential to his later achievements. The years between 1893 and 1898, roughly from the age of 3 to the age of 8, were years of growth and development for young Edwin, years during which he learned to read and write and do arithmetic, years during which he played with his siblings and made friends and absorbed the values and beliefs of his family, years during which he looked up at the night sky, whether from the backyard in Marshfield or from the suburban streets outside Chicago, and wondered about those distant points of light and what they might be, and though he could not have known it then, these quiet years of childhood were laying the foundation for a life that would eventually touch the stars themselves, not literally of course, but through the patient work of observation and measurement and thought that would reveal the true nature and scale of the universe in which we all find ourselves, floating on this small planet around an ordinary star in a galaxy that is itself just one among billions, a fact that was utterly unknown in 1898 but that Edwin Hubble, grown to manhood and armed with the tools of modern astronomy, would one day help to establish beyond any reasonable doubt, though all of that still lay far in the future, and for now he was simply a boy of 8, perhaps looking through his grandfather's telescope on a clear November evening, watching the stars wheel slowly overhead in their ancient and eternal dance, and feeling that first faint stirring of wonder that would one day blossom into a lifetime of discovery. In the year 1898, when Edwin was approaching his 9th birthday, the Hubble family made the decision to leave the state of Missouri and establish themselves in a new community, one that would shape the remainder of Edwin's formative years in ways both subtle and profound. The town they chose was Wheaton, Illinois, a modest settlement in DuPage County, situated some 25 miles to the west of Chicago, where the prairie lands stretched outward in gentle undulations and the pace of life moved according to rhythms quite different from those of the growing industrial centers nearby. John Powell Hubble, Edwin's father, had secured employment with an insurance firm, and the family's relocation represented both a professional opportunity and a chance to raise their growing number of children in surroundings that combined small-town familiarity with reasonable proximity to the economic possibilities of the greater Chicago region. Wheaton at the turn of the century was a community of perhaps 4,000 or 5,000 residents, a place where church steeples rose above the modest commercial district and where neighbors knew one another's names and circumstances with an intimacy that would have been impossible in larger urban settings. The town had been founded several decades earlier and had developed a character that was quietly prosperous without being ostentatious, religious without being severe, and progressive in its commitment to education while remaining rooted in traditional values regarding family, work, and civic responsibility. It was, in many respects, a thoroughly typical Midwestern American town of its era, and yet for the Hubble children it would provide the particular combination of influences and opportunities that would shape their individual trajectories into adulthood. The family settled into their new home, and the routine of daily life gradually established itself around the familiar patterns of school attendance, church participation, and the various domestic responsibilities that fell to each member of the household according to age and capability. Virginia Lee Hubble, Edwin's mother, maintained the home with the quiet efficiency that was expected of women of her generation and social standing, While John Powell Hubble provided both financial support and moral direction, his expectations for his children's futures communicated through a combination of explicit instruction and the implicit example of his own professional conduct. Edwin began his attendance at the Wheaton public schools, entering into the educational system that would guide him through the following years until his graduation from high school. The schools of Wheaton were neither exceptional nor deficient by the standards of the time, offering a curriculum that emphasized the fundamental skills of reading, writing, and arithmetic while gradually introducing students to broader subjects including history, geography, and the natural sciences. The classrooms were populated by the children of farmers, merchants, and professional men, creating a social environment that, while not perfectly egalitarian, allowed for association across various levels of economic standing. It was during these years of elementary and secondary education that Edwin's particular aptitudes began to reveal themselves, emerging gradually rather than bursting forth in any single dramatic demonstration. His teachers noted his facility with mathematical concepts, the ease with which he grasped numerical relationships and geometric principles that other students found challenging or tedious. There was nothing showy about his academic performance, no apparent desire to call attention to his own abilities, but rather a steady competence that placed him consistently among the better students in his classes. His work in the sciences, too, showed promise, an engagement with questions about the physical world that went beyond mere memorization of facts to encompass genuine curiosity about underlying mechanisms and principles. The influence of his grandfather's telescope, that formative experience of gazing upward into the summer sky, had not faded with the family's move to Illinois. Edwin continued to nurture an interest in astronomical matters, reading whatever materials he could obtain and observing the night sky when opportunity permitted, though his fascination remained one interest among several rather than an all-consuming passion. He was, after all, a young person with the varied enthusiasms and distractions common to his age, and his engagement with the cosmos competed for his attention with more immediately pressing concerns of school, family, and social life. John Powell Hubble maintained strict expectations regarding his children's conduct, their application to their studies, and their preparation for responsible adulthood. He was not a cruel father by any account, but neither was he given to excessive displays of warmth or indulgence. His approach to parenting reflected the prevailing attitudes of his time and class, which held that children benefited from firm guidance, clear boundaries, and the early development of self-discipline. Professional careers were the expected outcome for his sons, respectable occupations that would provide financial security and social standing while contributing meaningfully to the broader community. The law, medicine, and other established professions represented the appropriate aspirations for young men of good family, and John Powell Hubble made these expectations known to his sons through both direct conversation and the subtler influences of daily interaction. Edwin absorbed these expectations, as children inevitably absorb the values and ambitions of their parents, though the precise manner in which he would eventually fulfill or modify them remained to be determined by the unfolding of events still years in the future. For the present, he applied himself to his schoolwork with sufficient diligence to satisfy his father's requirements while also pursuing the various interests and activities that occupied young people of his age and circumstances. It was in the realm of athletics that Edwin began to distinguish himself most visibly from his peers, his physical abilities emerging during his years at Wheaton High School in ways that brought him recognition and acclaim within the community. He had grown tall, as his father was tall, eventually reaching a height of 6 feet and 2 inches, which placed him considerably above the average stature of his contemporaries. This height, combined with a naturally athletic build and a coordination that allowed him to translate size into effective movement, made him well suited to a variety of sporting activities. Track and field became the arena in which Edwin's athletic gifts found their fullest expression during his high school years. He competed in jumping events, demonstrating particular aptitude for the high jump and the pole vault, disciplines that rewarded the combination of height, timing, and technique that he possessed in unusual measure. The high jump of that era employed methods quite different from those used in contemporary competition, with athletes approaching the bar from an angle and clearing it in a scissors-like motion or with the Western roll technique, landing upon sawdust or sand pits that provided far less cushioning than modern foam surfaces. There exists a story, repeated in various accounts of Edwin's early life, concerning a remarkable performance at a state high school track meet, in which he is said to have set a record in the high jump that stood for some years thereafter. The precise details of this achievement have proven difficult to verify with complete certainty, as records from high school athletic competitions in the early 1900s were not always maintained with the rigor that would later become standard, and memory has a tendency to embellish accomplishments over the passage of decades. Whether the story represents an entirely accurate historical record or has been enhanced somewhat in the retelling, it reflects the genuine impression that Edwin made upon those who witnessed his athletic performances, an impression of unusual ability that set him apart from ordinary competitors. The pole vault likewise showcased his capabilities, the event requiring not only the height and strength to propel oneself over the bar but also the courage to launch one's body into the air while gripping a flexible pole and the technical precision to coordinate the complex sequence of movements involved in a successful vault. Edwin approached these challenges with evident enthusiasm, finding in athletic competition a sphere of activity in which his physical gifts could translate directly into measurable achievement and public recognition. Beyond the individual events of track and field, Edwin also participated in team sports during his years at Wheaton High School, contributing to football and basketball teams that competed against the squads of neighboring communities. Football in that period was a rougher and less regulated game than it would later become, with protective equipment that was minimal by contemporary standards and rules that permitted a degree of physical contact that would now be considered dangerous. Basketball was still a relatively young sport, having been invented only a few years before Edwin's birth, and it was developing its rules and conventions even as young athletes like Edwin learned to play it in school gymnasiums and on outdoor courts. His height gave him natural advantages in both sports, allowing him to see over opponents on the football field and to contest shots and rebounds on the basketball court with reach that shorter players could not match. Yet physical gifts alone do not make a successful team athlete, and Edwin's participation in these sports also required cooperation with teammates, acceptance of coaching, and the subordination of individual impulses to collective strategy, lessons that would serve him in various ways throughout his later life. The combination of athletic prominence and solid academic performance made Edwin a notable figure within Wheaton High School, a young man whose name was known not merely to his immediate circle of friends but to the broader community of students, teachers, and townspeople who followed the fortunes of the local athletic teams. His height made him visually distinctive, easy to spot in a crowd or on a playing field, and his accomplishments gave substance to the attention that his physical appearance might otherwise have attracted only briefly. Throughout these years, the Hubble family maintained regular attendance at church, participating in the religious life of the community in accordance with the expectations of respectable middle-class families of the period. Edwin was confirmed in the Christian faith, undergoing the ritual that marked his formal acceptance into the adult membership of the church and his acknowledgement of the religious beliefs in which he had been raised. The precise nature of his personal engagement with matters of faith during this period of his life is difficult to determine from the available evidence, as young people often participate in religious observances as a matter of family routine without yet having formed the independent convictions that will characterize their adult spiritual lives. What can be said with confidence is that the religious environment of his upbringing contributed to the broader framework of values and assumptions within which he understood himself and his place in the world. The questions of ultimate meaning and cosmic purpose that religion addresses were woven into the fabric of his early experience, even if the specific forms those questions would eventually take in his scientific work lay far beyond what anyone, including Edwin himself, could have anticipated during his high school years. The discipline imposed by his father found expression not only in expectations regarding academic and professional achievement but also in the structure of daily life within the Hubble household. Chores were assigned and expected to be completed, schedules were maintained, and the various children were held accountable for their conduct and their obligations. This environment cultivated habits of responsibility and self-regulation that would prove valuable in Edwin's later pursuits, even as it may have also generated tensions and pressures that remained largely invisible to outside observers. As Edwin progressed through the grades of Wheaton High School, his teachers continued to note his abilities in mathematics and science, subjects that seemed to engage his intellectual curiosity in ways that other areas of the curriculum did not. There was something in the precision of mathematical reasoning, the way in which complex relationships could be expressed through elegant equations, that appealed to his mind and drew forth his best efforts. science offered the additional satisfaction of connecting abstract reasoning to observable phenomena, of testing ideas against the evidence of the physical world and refining understanding through systematic investigation. These academic interests developed alongside rather than in competition with his athletic pursuits, the two domains of achievement existing in a kind of parallel that would characterize much of his undergraduate experience as well. He was neither the pure scholar who disdained physical activity nor the pure athlete who neglected intellectual development, but rather a young person in whom both capacities found room for expression and growth. The year 1906 brought Edwin's high school career to its conclusion, as he completed the requirements for graduation and prepared to take the next step in his educational journey. He graduated with honors, his academic record reflecting the consistent application of his abilities across the years of secondary schooling. The ceremonies that marked this transition were modest by later standards, appropriate to the scale of the community and the expectations of the era, but they represented nonetheless a significant milestone in the life of a young man who was preparing to leave the familiar surroundings of his hometown. At 17 years of age, Edwin Hubble had developed into a tall, capable, and promising young person whose achievements in both athletics and academics had marked him as someone of unusual potential. The precise direction that potential would take remained to be determined, shaped by choices still to be made and opportunities still to present themselves, but the foundation had been laid during those years in Wheaton, in the classrooms of the public schools and on the athletic fields where he had discovered capabilities he had not known he possessed. The small town had done its work of preparation, providing the education, the experiences, and the environment within which a particular set of gifts could begin to reveal themselves. What would come next would carry Edwin beyond the boundaries of DuPage County and into wider worlds of learning and achievement, but the years in Wheaton would remain part of him, a layer of formation upon which subsequent experiences would build. The prairie town with its church steeples and its public schools had nurtured the early growth of a person who would eventually turn his attention to questions of cosmic scope, though none of this could have been foreseen by those who watched him receive his diploma and offer his farewells to classmates and teachers in that early summer of 1906. In the autumn of 1906, a young man from the small town of Wheaton, Illinois, made his way to the imposing limestone buildings of the University of Chicago, carrying with him an academic scholarship and the quiet ambitions that had been forming throughout his boyhood years of reading and wondering about the night sky. Edwin Hubble was 17 years old when he enrolled at this relatively young but remarkably ambitious institution, which had been founded only 14 years earlier with funding from John D. Rockefeller and had already begun to establish itself as a serious center of scientific research in the American Midwest. The campus spread across the flat prairie land of the south side of Chicago, its Gothic architecture rising somewhat unexpectedly from the surrounding urban landscape, and it was here that Hubble would spend the next 4 years developing the intellectual foundations that would eventually lead him to transform our understanding of the universe itself, though of course at the time he was simply a bright young undergraduate beginning his studies like so many others before and after him. The University of Chicago in those early years of the 20th century was a place of considerable intellectual ferment, where the traditional boundaries between academic disciplines were being questioned and where ambitious young scholars could find mentors who were themselves pushing at the edges of human knowledge. Hubble declared his major in mathematics and astronomy, a combination that suited his particular cast of mind, which seemed to blend a facility for abstract reasoning with a genuine curiosity about the physical workings of the cosmos. He also took up a minor in physics, rounding out his scientific education with the practical and theoretical tools that would serve him well in his later observational work. This combination of mathematical rigor, astronomical knowledge, and physical intuition would prove to be precisely the preparation needed for the discoveries that lay decades ahead, though at the time it was simply the curriculum that appealed most naturally to his interests and abilities. Among the professors who shaped young Hubble's understanding of the cosmos, Forrest Ray Moulton stands out as a particularly significant figure in his astronomical education. Moulton was a mathematical astronomer of considerable reputation, known for his work on celestial mechanics and for his contributions to what was then called the planetesimal hypothesis of solar system formation, which he had developed in collaboration with the geologist Thomas Chamberlain. In Moulton's classes, Hubble would have encountered the rigorous application of mathematical methods to astronomical problems, learning how the careful analysis of observations could reveal the underlying physical processes governing the motions of celestial bodies. Moulton was the sort of teacher who demanded precision and clarity of thought, and his influence can perhaps be detected in the methodical approach that Hubble would later bring to his own astronomical investigations. The lectures in astronomy introduced the young student to the state of knowledge as it existed in the first decade of the century, a time when many fundamental questions about the nature and extent of the universe remained deeply uncertain and when the tools for answering such questions were only beginning to be developed. In the physics department, Hubble had the good fortune to study under Robert Andrews Millikan, who would later become one of the most celebrated American physicists of his generation and who would eventually receive the Nobel Prize for his precise measurements of the charge of the electron and for his work on the photoelectric effect. Millikan was a demanding teacher and a meticulous experimenter, and he recognized in Hubble a student of unusual ability and dedication. This recognition led to Hubble being offered a position as a laboratory assistant to Millikan, a role that allowed him to participate directly in the careful experimental work that characterized physics research at Chicago during this period. Working alongside Millikan in the laboratory, Hubble would have absorbed not only technical skills but also an appreciation for the importance of precise measurement and careful control of experimental conditions, habits of mind that would transfer readily to the astronomical observations he would later conduct. The experience of assisting in genuine research, rather than simply attending lectures and completing assigned exercises, gave Hubble an early taste of what it meant to push beyond the boundaries of established knowledge, and it seems likely that this experience strengthened his growing inclination toward a life devoted to scientific inquiry. Yet for all his academic seriousness, Hubble was by no means the sort of student who confined himself to the library and the laboratory. His physical gifts, which had been evident since his schoolboy days, continued to find expression in athletic competition throughout his undergraduate years, and he achieved considerable distinction in multiple sports during his time at Chicago. He lettered in track and field, where his height and natural coordination served him well in events that demanded both power and precision. His performances on the track were sufficiently notable to earn him recognition among his peers, and athletics provided a counterbalance to the intellectual demands of his coursework, allowing him to maintain the physical vigor that seemed so much a part of his character. The combination of scholarly achievement and athletic prowess was not uncommon among ambitious young men of that era, who often aspired to a kind of well-rounded excellence that encompassed both mind and body, and Hubble seems to have embodied this ideal with particular success. The 1909 basketball season brought Hubble perhaps his greatest athletic achievement during his college years, as he played on the University of Chicago team that went through their entire schedule without suffering a single defeat. Basketball in that era was a rather different game than the one played today, with lower scores, different rules, and a style of play that emphasized teamwork and fundamental skills over individual athleticism, but the accomplishment of an undefeated season was no less meaningful for those who achieved it. Hubble's height, which was considerable for that time, would have made him a valuable presence on the court, and his competitive nature, which was evident in all his endeavors, surely contributed to the team's success. The camaraderie of athletic competition and the satisfaction of shared victory provided experiences quite different from those of the classroom and the laboratory, and they helped to shape Hubble into the confident, socially adept individual he would become in later life. His teammates remembered him as someone who combined natural ability with a genuine commitment to the team's collective success, and the experience of being part of an undefeated squad surely reinforced his appetite for achievement and excellence. Alongside his athletic activities and his scientific studies, Hubble found time for broader intellectual explorations that went beyond the requirements of his formal curriculum. It was during these university years that he encountered the cosmological writings of Immanuel Kant, the 18th-century German philosopher whose ideas about the nature and structure of the universe had proven remarkably prescient in certain respects. Kant had proposed, in his work on the theory of the heavens published in 1755, that the faint nebulous patches visible in the night sky might in fact be distant collections of stars similar to our own Milky Way, what he called island universes scattered throughout infinite space. This idea, which Kant had developed through a combination of philosophical reasoning and informed speculation, anticipated by more than a century and a half the discoveries that Hubble himself would eventually make regarding the true nature of the spiral nebulae. Reading Kant's cosmological ideas during his formative years may have planted seeds in Hubble's imagination, or perhaps it simply resonated with intuitions he already possessed about the grandeur and extent of the cosmic realm. Either way, this engagement with philosophical thought about the universe suggests that Hubble's interests extended beyond the purely technical and mathematical aspects of astronomy to encompass deeper questions about humanity's place in the larger scheme of things. The academic recognition that Hubble received during his undergraduate years reflected the exceptional quality of his scholarly work across multiple disciplines. His election to Phi Beta Kappa, the prestigious honor society founded in 1776 at the College of William and Mary and dedicated to the celebration of excellence in the liberal arts and sciences, marked him out as among the most distinguished students in his class. Membership in Phi Beta Kappa was awarded on the basis of academic achievement, and the honor signified that Hubble had demonstrated not merely competence but genuine distinction in his studies. The Society's motto, which translates roughly as "Love of learning is the guide of life," captured something of the spirit that seems to have animated Hubble during these formative years, a genuine passion for understanding that went beyond mere credentialism or careerism. His fellow Phi Beta Kappa members included some of the brightest minds of his generation, and his inclusion among them confirmed what his professors had already recognized, that Edwin Hubble possessed intellectual gifts of an uncommon order. As his undergraduate years drew toward their conclusion, Hubble began to consider the next steps in his education and career, and his attention turned toward an opportunity that would take him far from the prairies of Illinois to one of the ancient seats of learning in England. The Rhodes Scholarship Program, established through the will of the British mining magnate Cecil Rhodes, had begun awarding scholarships to American students in 1904, just a few years before Hubble would apply. The scholarships provided funding for study at the University of Oxford, and they were awarded on the basis of a combination of academic achievement, athletic ability, leadership qualities, and moral character, a set of criteria that seemed almost perfectly designed to favor candidates of Hubble's particular profile. The competition for these scholarships was intense, drawing the most accomplished young men from universities across the country, and winning one required not only an impressive record of achievement but also the ability to present oneself favorably in the selection process. In 1910, Edwin Hubble applied for a Rhodes Scholarship and was successful, becoming one of the earliest recipients from the state of Illinois. The selection committees were evidently impressed by the combination of qualities he presented: the outstanding academic record with its Phi Beta Kappa recognition and high honors, the athletic achievements including the track letters and the undefeated basketball season, and presumably also the personal qualities that emerged in interviews and from letters of recommendation. The award of the scholarship represented a validation of everything Hubble had accomplished during his 4 years at Chicago, and it opened before him the prospect of continuing his education at one of the most venerable universities in the world. The opportunity to study at Oxford carried with it not only educational benefits but also a certain social prestige, and for a young man from a modest Midwestern background, the Rhodes Scholarship represented an entry into circles that might otherwise have remained closed to him. The same year that brought the triumph of the Rhodes Scholarship also saw Hubble complete his undergraduate degree with honors in astronomy and mathematics, the two subjects that had most fully engaged his intellectual energies during his years at Chicago. The degree represented the formal conclusion of his American undergraduate education, though it was really just the beginning of a much longer journey of learning and discovery. The honors designation recognized the exceptional quality of his work in his major fields, and it confirmed what his election to Phi Beta Kappa had already indicated, that Hubble had distinguished himself even among the distinguished company of students who attended the University of Chicago in that era. With his degree in hand and his Rhodes Scholarship secured, Hubble prepared to cross the Atlantic and begin the next phase of his education in the ancient stone quadrangles of Oxford. Yet even as these prospects of opportunity and advancement opened before him, the Hubble family faced challenges that would cast a shadow over the years ahead. Edwin's father, John Powell Hubble, had been dealing with health difficulties, and his condition would continue to decline in the years following Edwin's departure for England. John Hubble would pass away in 1913, while Edwin was still pursuing his studies abroad, and this loss would bring not only grief but also significant practical consequences for the family. The financial pressures created by John's death would fall heavily on Edwin as the eldest son, creating obligations that would complicate his plans and constrain his choices in ways that a young man at the threshold of a promising academic career could hardly have wished. The shadow of this future loss, though still a few years distant when Hubble completed his bachelor's degree and prepared for Oxford, would eventually shape the course of his early career in ways that might not have been predicted from the triumphant circumstances of 1910. But that difficult time still lay ahead, beyond the immediate horizon of planning and anticipation, and for now the young graduate could look forward to the adventure that awaited him in England, where new teachers, new subjects, and new experiences would continue the process of intellectual and personal formation that had begun in the prairies of the Midwest and continued in the laboratories and classrooms of Chicago. In the autumn of 1910, Edwin Hubble crossed the Atlantic Ocean aboard a steamship bound for England, carrying with him a Rhodes scholarship and the quiet weight of his father's expectations. He was 20 years old, recently graduated from the University of Chicago with a degree in mathematics and astronomy, and he had been selected as one of 32 young American men to study at the University of Oxford that year. The Rhodes Scholarship, established just 8 years earlier through the bequest of the British mining magnate Cecil Rhodes, was designed to bring promising students from the United States, Germany, and the British colonies to Oxford, where they might absorb something of the English educational tradition and carry it back to their home countries. For Hubble, this represented both an extraordinary opportunity and a compromise, for although he had distinguished himself in his astronomical studies under the guidance of Professor Forrest Ray Moulton at Chicago, and although his deepest intellectual passion lay in understanding the nature of the stars and nebulae, his father John Powell Hubble had made it clear that he expected his son to pursue a more practical profession, one that would provide financial security and social standing in a way that stargazing, however noble, could not guarantee. John Hubble was a man of firm opinions, an insurance executive who had moved his family from Missouri to Illinois to Kentucky as his career demanded, and who held traditional views about what constituted a respectable livelihood for an educated man. Law, in his estimation, was such a profession, and so it was agreed that Edwin would read jurisprudence at Oxford rather than continue his studies in the physical sciences. This was not an unusual arrangement for the time, as many young men of Hubble's generation found themselves navigating between their own inclinations and the practical wisdom of their elders, and the Rhodes Scholarship itself did not specify a particular field of study, leaving the choice to the scholar and, in many cases, to his family. And so Edwin Hubble arrived at Queen's College, Oxford, in October of 1910, enrolled not as a student of astronomy or physics, but as a student of law, preparing to learn the intricacies of legal reasoning that might one day serve him in an American courtroom or corporate office. Queen's College sits along the High Street in the centre of Oxford, its classical facade designed by Nicholas Hawksmoor in the early 18th century, presenting a screen of columns and pediments to passers-by while enclosing quiet quadrangles within. The college had been founded in the 14th century, and by the time Hubble took up residence there, it had accumulated nearly 600 years of tradition, ritual, and expectation. Students wore academic gowns to lectures and formal dinners, observed ancient customs whose origins had long been forgotten, and moved through days structured by chapel bells and the rhythms of the academic term. For a young man from the American Midwest, even one who had attended a distinguished university in Chicago, the experience of Oxford must have felt both foreign and intoxicating, a glimpse into a world of learning that stretched back through centuries and connected the present to the deep past of European intellectual life. The curriculum Hubble followed in jurisprudence was demanding in its own particular way, requiring him to master bodies of legal knowledge that formed the foundation of the Western legal tradition. He read Roman law, studying the Corpus Juris Civilis compiled under the Byzantine Emperor Justinian in the 6th century, which had codified centuries of Roman legal thought into a systematic body of principles concerning property, contracts, obligations, and the rights of persons. This was law as an intellectual architecture, a framework for organizing human relationships that had influenced legal systems across Europe for more than 1,000 years. Alongside the Roman tradition, Hubble studied English common law, that distinctive body of legal reasoning developed through centuries of judicial decisions in English courts, in which precedent built upon precedent and the law emerged not from legislative codes but from the accumulated wisdom of individual judgments. He learned the language of writs and pleadings, the procedural complexities of the courts of common law and equity, and the particular English genius for finding practical solutions within inherited forms. The method by which Hubble received his education at Oxford was the tutorial system, a distinctive approach to teaching that set Oxford and Cambridge apart from most other universities of the world. Rather than attending large lectures as the primary mode of instruction, students at Oxford met regularly with tutors in small groups of 1, 2, or 3, gathering in the tutors' rooms to read essays aloud and submit to close questioning about the texts they had studied. The tutor might interrupt, challenge, probe, and redirect, demanding that the student defend his arguments, clarify his reasoning, and reconsider his assumptions. This method placed enormous emphasis on the student's own preparation and thought, requiring him to engage actively with the material rather than passively absorbing information delivered from a lectern. For a mind like Hubble's, already trained in the rigors of scientific reasoning, the tutorial system offered a different kind of intellectual discipline, one focused on argument, evidence, and the careful construction of persuasive prose. Whether or not he found the content of his legal studies particularly compelling, the method by which he learned it would have sharpened skills of analysis and expression that would serve him throughout his life. During his years at Oxford, Hubble underwent a transformation that went beyond the merely intellectual, adopting aspects of English style and manner that would remain with him for the rest of his life. He began to wear tweed suits of the kind favored by English gentlemen, well-cut and substantial, appropriate for the damp climate and the informal elegance of collegiate life. He took up pipe smoking, that quintessentially British habit, learning to pack and light and draw upon the pipe with the unhurried ritual that the practice demanded. Most notably, and most remarked upon by those who knew him later, he began to affect certain features of British speech, adopting vocabulary, pronunciation, and cadence that marked him as someone who had spent formative years in England. He used British spellings in his correspondence, writing color and honor and behavior, and these habits persisted long after he had returned to America, giving his written and spoken language a transatlantic flavor that some found charming and others found affected. Whether this was a conscious performance or a natural absorption of his surroundings is difficult to say, but it became so thoroughly a part of his persona that those who met him in later years often assumed he had English ancestry or had spent far longer abroad than he actually had. Beyond his studies, Hubble threw himself into the athletic life of the college with characteristic energy, joining the Queen's College rowing crew and taking his place in one of the long, narrow boats that glided along the river during training and competition. Rowing at Oxford was both sport and social institution, requiring early morning practices, close coordination with crewmates, and the particular combination of endurance, strength, and rhythm that the sport demands. The rivers around Oxford, the Thames, and its tributaries, provided the setting for this ancient tradition, and the races between college boats were occasions of considerable excitement and college pride. For Hubble, who had been an athlete since childhood and who had earned a letter in track and field at the University of Chicago, rowing offered a way to belong, to participate in the physical culture of the university alongside the intellectual culture of the tutorial room. He also continued to box during his Oxford years, having developed skill in the sport during his undergraduate days in Chicago. There are stories, repeated in various accounts of his life, that he fought a match against a French champion during this period, though the details of this alleged bout are difficult to verify and may have grown in the telling over the years. What is certain is that Hubble was a capable boxer, tall and powerfully built, with the reach and the competitive temperament that the sport requires. Whether he actually faced a French champion in some unofficial match during his European travels, or whether this was an embellishment that attached itself to his reputation, the story became part of the Hubble legend, contributing to the image of a man who was as formidable physically as he was intellectually. During the long vacations that punctuated the Oxford academic year, Hubble traveled on the continent, visiting Germany, France, and Spain, experiencing something of the cultural richness of pre-war Europe. These were the final years before the catastrophe of the First World War would transform the continent, and a young man with modest means and an adventurous spirit could move relatively freely across borders, visiting the great cities, walking through museums and cathedrals, and absorbing impressions that would broaden his understanding of human civilization and its achievements. We do not have detailed records of these journeys, but we know that Hubble took advantage of the opportunities his Oxford years provided to see something of the world beyond England, storing up experiences that would inform his later life even as his primary attention remained directed toward other matters. Throughout his time at Oxford, despite his official commitment to the study of law, Hubble continued to read privately in astronomy. The passion that had been kindled in his childhood, when he had looked through his grandfather's telescope at the summer stars, and that had been nurtured by his studies under Professor Moulton at Chicago, did not disappear simply because his father had directed him toward a different profession. He kept up with developments in the field as best he could, reading journals and books, following the work of astronomers who were beginning to unlock the secrets of the nebulae and the structure of the universe. This was a period of considerable ferment in astronomy, as new photographic techniques and larger telescopes were revealing details of celestial objects that had never been seen before, and questions about the nature of the spiral nebulae, whether they were clouds of gas within our own Milky Way or separate island universes far beyond it, were being debated with increasing intensity. Hubble could not have known, during those quiet evenings in his Oxford rooms, that he would one day provide the decisive evidence that would settle this debate, but he was laying the groundwork, keeping his mind engaged with the questions that would eventually define his life's work. In the winter of 1913, Edwin Hubble received news from America that changed the course of his immediate future. His father, John Powell Hubble, had died, apparently from complications related to malaria, a disease he may have contracted during his earlier years. The loss of his father removed the primary source of pressure that had directed Hubble toward the law, but it also created practical responsibilities, as he was now one of the older children in a family that included his mother and several siblings. He completed his studies at Oxford, receiving his degree in jurisprudence, and returned to the United States to take up whatever employment he could find to support himself and contribute to his family. What followed was a brief and unhappy period that Hubble rarely spoke of in later years. Unable to find a position in law or astronomy, he took a job teaching at New Albany High School in Indiana, a small town across the Ohio River from Louisville, Kentucky. There he taught Spanish and physics to high school students, subjects that required him to draw on different aspects of his education, and he also served as the coach of the school's basketball team. For a young man who had walked the quadrangles of Oxford, who had rowed on the English rivers and debated jurisprudence with learned tutors, the experience of teaching adolescents in a provincial American high school must have felt like a considerable diminishment. He was 24 years old, overqualified for his position, and uncertain about his future. The affectations he had acquired in England, the British accent and vocabulary, the tweed suits and the pipe, must have seemed out of place in New Albany, and one can imagine the quiet frustration of a man who knew his capabilities but had not yet found the path that would allow him to exercise them. This period lasted only about a year, from 1913 into 1914, and it was soon followed by decisions that would redirect Hubble's life toward the work for which he would be remembered. But for a time, the future discoverer of the expanding universe stood before chalkboards in Indiana, explaining the conjugation of Spanish verbs and the principles of mechanics, and coaching young men in the fundamentals of basketball, waiting for the opportunity that would allow him to return to the study of the stars. After a year of practicing law in Louisville, Kentucky, Edwin Hubble found himself increasingly unable to ignore the quiet but persistent pull of the stars. The legal profession, respectable and financially secure as it was, had begun to feel like a garment cut for someone else, and though he fulfilled his duties to his clients with characteristic diligence, his evenings were spent reading astronomical journals and his thoughts wandered frequently to the great telescopes he had glimpsed during his time at Oxford and before. The death of his father in early 1914 seems to have clarified something within him, removing perhaps a certain filial pressure to pursue conventional success, and freeing him to reconsider the path his life might take. By the spring of that year, Hubble had made his decision, writing letters to several universities to inquire about graduate programs in astronomy, and ultimately choosing to return to the place where his scientific inclinations had first been encouraged, the University of Chicago. The university's graduate program in astronomy was centered upon Yerkes Observatory, situated not in Chicago itself but in the small town of Williams Bay, Wisconsin, some 80 miles to the north. This arrangement meant that serious students of the heavens would spend much of their time in a rural setting of considerable tranquility, far from the lights and noise of the growing city, surrounded by the gentle Wisconsin landscape of rolling farmland and quiet lakes. The observatory had been established in the 1890s through the generosity of Charles Tyson Yerkes, a Chicago businessman of complicated reputation, and it had been designed from the beginning to house what was then, and would remain for some years, the largest refracting telescope ever constructed. Edwin Hubble arrived at this institution in the autumn of 1914, a man of 24 years who had already demonstrated abilities in athletics, scholarship, and the law, now ready to devote himself entirely to the patient and painstaking work of understanding the universe. The director of Yerkes Observatory at this time was Edwin Frost, a kindly and methodical astronomer who had led the institution since 1905. Frost was known for his work in stellar spectroscopy, the study of the light emitted by stars and what that light could reveal about their composition and motion, and he maintained the observatory as a place of careful research and thorough training. Though his eyesight had begun to fail him by the time Hubble arrived, a cruel irony for one whose profession depended upon vision, Frost remained an effective administrator and a supportive mentor to his graduate students. He recognized in Hubble a combination of intellectual sharpness and observational patience that suggested the young man might accomplish significant things, and he agreed to serve as the advisor for Hubble's doctoral research. The relationship between the two Edwins, as one might gently note, was cordial and productive, characterized by the mutual respect of teacher and capable student. The great telescope that dominated Yerkes Observatory was its 40-inch refractor, an instrument of remarkable dimensions that had been completed in 1897. A refracting telescope gathers and focuses light using lenses rather than mirrors, and the main lens of the Yerkes instrument measured 40 inches in diameter, a size that represented the practical limit of what could be achieved with lens-based designs. Larger lenses would sag under their own weight, distorting the images they produced, and so the Yerkes refractor stood then and stands now as the largest of its type ever successfully operated. The telescope tube stretched some 60 feet in length and was housed within a dome 90 feet in diameter, the entire assembly capable of being rotated and tilted to bring any portion of the visible sky into view. For a young astronomer beginning his serious research, access to such an instrument was a considerable privilege, though Hubble would find himself working more frequently with a somewhat smaller telescope better suited to his particular investigations. This was the 24-inch reflector, a telescope that gathered light using a curved mirror rather than a lens, and which proved especially well suited to the photographic work that Hubble wished to pursue. Reflecting telescopes had certain advantages for studying faint and distant objects, as mirrors could be made larger than lenses and could gather more of the sparse light arriving from remote celestial sources. The 24-inch reflector at Yerkes was a capable instrument for its time, and Hubble spent many long nights positioning it toward various nebulae, those mysterious cloudy patches of light that had puzzled astronomers for generations. The photographic plates he exposed during these sessions would capture light that had traveled immense distances across the darkness of space, recording on their silver-coated surfaces the faint glow of objects whose true nature remained uncertain. Hubble's dissertation research focused upon these nebulae, and carried the appropriately measured title of Photographic Investigations of Faint Nebulae. The work required him to spend countless hours at the telescope, guiding the instrument with careful adjustments as the Earth's rotation carried the stars slowly across the sky, ensuring that the photographic plates received steady exposures sometimes lasting an hour or more. Afterwards, the plates had to be developed and examined, their dim images measured and catalogued, their positions and brightnesses recorded with the precision that astronomical work demanded. It was methodical labor, the sort of patient accumulation of data upon which scientific understanding is gradually built, and it suited Hubble's temperament well. He was not seeking dramatic discoveries during these years so much as contributing to the slow and careful mapping of the celestial realm. The nebulae that Hubble photographed and studied presented astronomers of that era with a genuine puzzle, one that had persisted for over a century without definitive resolution. Some of these cloudy objects were clearly associated with the Milky Way, the great band of stars that arched across the night sky and which was understood to represent our own galaxy seen from within. These galactic nebulae, as they came to be called, included clouds of glowing gas illuminated by nearby stars, and clusters of stars too distant to be resolved as individual points of light but appearing instead as hazy patches. Other nebulae, however, possessed a distinctly different character, showing spiral structures or elliptical shapes that suggested they might be something else entirely, perhaps vast collections of stars lying far beyond the boundaries of our own Milky Way. This possibility, that some nebulae were in fact separate galaxies comparable in size and scope to our own, was known as the island universe hypothesis, and it remained one of the great unresolved questions in astronomy. Hubble's early classification work touched upon this distinction, as he attempted to sort the various nebulae he observed into categories based upon their appearance and characteristics. He noted which objects seemed to be embedded within the star fields of the Milky Way and which seemed to exist apart from them, though he was careful not to claim definitive conclusions about their true distances or natures. The question of whether spiral nebulae were relatively nearby objects within our galaxy or tremendously distant systems beyond it would not be settled for another decade, and the young graduate student was prudent enough to recognize the limits of what his observations could establish. Nevertheless, this early work on nebula classification laid the foundation for the discoveries that would eventually make his name famous throughout the world. Among his fellow graduate students at Yerkes, Hubble found a small community of dedicated young astronomers, each pursuing their own research under the guidance of the observatory's faculty. The graduate students shared meals and conversations, discussed their observations and their interpretations, and formed the kinds of collegial bonds that often develop among those engaged in similar intellectual pursuits. Hubble was remembered by some of his peers as somewhat reserved, possessing a certain formality of manner that may have been a lingering effect of his time at Oxford, where he had absorbed something of the English academic style. He could be charming and good-humored in social settings, yet there was also about him an air of self-possession, a sense that he held some part of himself apart. These impressions varied among those who knew him, as impressions of any complex person inevitably do, but there is no indication that he was disliked or isolated during his years at Yerkes. While Hubble pursued his research in Wisconsin, significant developments were occurring elsewhere in the astronomical world that would prove highly relevant to his future work. In 1914, the same year that Hubble began his graduate studies, an astronomer named Vesto Melvin Slipher, working at Lowell Observatory in Arizona, published measurements that would eventually help transform our understanding of the universe. Slipher had been studying the spectra of spiral nebulae, analyzing the light they emitted to determine their properties, and he had discovered something quite unexpected. The spectral lines in the light from many of these nebulae were shifted toward the red end of the spectrum, a phenomenon that indicated the objects were moving away from us at considerable velocities. This redshift, as it came to be known, suggested that the spiral nebulae were receding from the Earth at speeds of hundreds of miles per second, velocities far greater than those observed for stars within our own galaxy. Hubble followed these developments with considerable interest, recognizing their potential significance for the questions he was investigating. If the spiral nebulae were truly moving away from us at such tremendous speeds, this fact bore upon the question of their nature and distance. Objects within our own galaxy, bound by its gravitational influence, would not be expected to show such extreme velocities, whereas independent systems lying far beyond might well exhibit such motion. Slipher's measurements did not by themselves resolve the island universe debate, as alternative interpretations remained possible, but they added an important piece to the puzzle that astronomers were gradually assembling. The young graduate student in Wisconsin took note of this work and filed it away in his memory, where it would remain until circumstances allowed him to pursue its implications more fully. The years at Yerkes were not entirely consumed by telescopes and photographic plates, as Hubble maintained some of the broader interests that had characterized his earlier life. He remained physically active, enjoying outdoor pursuits when time and weather permitted, and he continued to read widely in fields beyond astronomy. The First World War had begun in Europe during the summer of 1914, casting a long shadow over the world even as Hubble commenced his studies, and the conflict would eventually touch his life directly. For the moment, however, America remained at peace, and the observatory in Wisconsin provided a quiet retreat where the concerns of nations at war could be temporarily set aside in favor of the eternal questions posed by the stars. By early 1917, Hubble had completed the requirements for his doctoral degree, and his dissertation on the photographic investigation of faint nebulae was accepted by the university. He was now Dr. Edwin Hubble, an astronomer with proper credentials and genuine expertise, ready to take his place among the professional practitioners of celestial science. His work at Yerkes had demonstrated both his technical competence and his capacity for original thought, and it had brought him to the attention of those who mattered in the astronomical community. One such person was George Ellery Hale, the visionary astronomer who had founded Yerkes Observatory itself and who now directed an even more impressive facility in California, the Mount Wilson Observatory above Pasadena. Hale had been following the progress of promising young astronomers throughout the country, always seeking talented individuals to staff his observatories and advance his ambitious research programs. He had built upon the flanks of Mount Wilson a telescope of unprecedented power, a 60-inch reflector that was then the largest operational telescope in the world, and he was already planning an even greater instrument, a 100-inch reflector that would surpass anything yet conceived. For such telescopes, Hale needed observers of skill and dedication, and Edwin Hubble seemed to possess exactly the qualities required. An offer was extended to join the Mount Wilson staff upon completion of his doctorate, an opportunity that any young astronomer would have found extraordinarily appealing. Hubble accepted the offer with gratitude and anticipation, looking forward to the possibilities that awaited him on that California mountainside. The great reflector at Mount Wilson, with its 60-inch mirror gathering the faint light of distant nebulae, would allow him to pursue questions that could barely be approached with the smaller instruments at Yerkes. He began to make preparations for the move westward, imagining the observations he would undertake and the discoveries that might follow. Yet even as he completed his dissertation and received his degree, events beyond his control were preparing to intervene. In April of 1917, the United States declared war upon Germany, entering at last the great conflict that had been consuming Europe for nearly 3 years, and young men across the nation found their personal plans suddenly subordinated to the demands of the state. Hubble made the decision to delay his acceptance of the Mount Wilson position in order to serve his country, a choice that reflected both the patriotic sentiments of the time and his own sense of duty. He communicated this decision to Hale, who accepted it with understanding, assuring the young astronomer that a place would be held for him when the war concluded and he was able to take up his astronomical work once more. The telescopes of Mount Wilson would wait, their mirrors continuing to gather starlight night after night, until Edwin Hubble could return from whatever experiences the war might bring and finally begin the work for which his years of preparation had fitted him. And so, as 1917 advanced and America mobilized for war, the newly minted Dr. Hubble set aside his astronomical ambitions temporarily and turned his attention to more immediate and earthly concerns, trusting that the stars and nebulae would still be there when peace returned and he could resume his patient study of the cosmos. In the spring of 1917, Edwin Hubble found himself at a crossroads that would briefly divert the course of his scientific journey, though perhaps divert is not quite the right word, for the path he chose was one that many young men of his generation felt compelled to walk, and he walked it with the same deliberate conviction he had brought to his studies of the faint nebulae. The United States had entered the Great War in April of that year, and Hubble, who had spent the preceding months absorbed in the final preparations of his doctoral dissertation at Yerkes Observatory, made a decision that would delay his astronomical career by more than 2 years, a delay that might seem significant when measured against the urgency of scientific discovery, but which, in the longer accounting of a life's work, would prove to be merely a pause, a quiet interlude before the great observations that lay ahead. He had completed his dissertation just days before, having successfully defended his work on the photographic investigation of faint nebulae, that careful study of the dim and distant objects that would later become the foundation of his most profound contributions to human understanding. The dissertation itself was a methodical piece of work, cataloguing and measuring these ghostly patches of light with the patience and precision that would characterize all of his subsequent research, and it had earned him his doctoral degree from the University of Chicago, adding the credential of Doctor of Philosophy to the already considerable list of his academic achievements. But there was little time for celebration or for the quiet satisfaction that might normally accompany such an accomplishment, for the world beyond the observatory walls was in turmoil, and Hubble felt the pull of duty as keenly as he had ever felt the pull of the stars. George Ellery Hale, the visionary director of the Mount Wilson Observatory in California, had extended to Hubble an invitation of considerable significance, offering him a position at what was then the finest astronomical facility in the world, home to the great 60-inch reflecting telescope and soon to house the even more magnificent 100-inch Hooker telescope that was then under construction. It was precisely the opportunity that any young astronomer would have dreamed of, a chance to work with instruments of unprecedented power, to peer deeper into the cosmos than any human being had peered before, and Hale had recognized in Hubble the qualities of mind and temperament that would make the most of such opportunities. But Hubble's reply to this generous invitation was brief and characteristic of the man, for he reportedly telegraphed Hale with a message that conveyed both his regret and his resolve in the fewest possible words, explaining that he could not accept the invitation because he was off to war. The telegram, if the accounts are accurate, was a model of economy, and it left no room for negotiation or delay, for Hubble had already made his decision, and it was not in his nature to equivocate once a course of action had been determined. He enlisted in the United States Army almost immediately after the defense of his dissertation, joining the great wave of young Americans who were answering their country's call to arms, and he was sent to Fort Sheridan in Illinois for his officer training. Fort Sheridan was one of the primary facilities where the Army prepared its new officers for the responsibilities of command, a place of drill fields and barracks and the particular rhythms of military life that would have been quite different from anything Hubble had known at Oxford or Yerkes or in his brief time as a schoolteacher in Indiana. The training was rigorous and methodical, designed to transform civilians into soldiers capable of leading other men into the uncertainties of battle, and Hubble applied himself to this new discipline with the same thoroughness he had brought to his scientific work, learning the arts of military organization and tactics and the management of men under conditions of stress and danger. His physical bearing served him well in this environment, for he was a tall man, well over 6 feet, with an athletic frame that had been honed by his years of sporting achievement, and he carried himself with a natural authority that inspired confidence in those around him. The military life, with its clear hierarchies and its emphasis on precision and order, seems to have suited some aspect of his temperament, and he advanced through his training with distinction, emerging with a commission as a captain in the United States Army. He was assigned to the 343rd Infantry Regiment of the 86th Division, a unit that bore the nickname of the Black Hawk Division in honor of the great Sauk leader who had once waged war in the very region where many of the division's soldiers had been recruited, and Hubble took his place among its officers with a sense of purpose and readiness. The division was assembled and trained at Camp Grant, another military installation in Illinois, where thousands of young men were being prepared for the great endeavor of overseas combat. Camp Grant was a sprawling facility that had sprung up almost overnight to meet the demands of the mobilization, a temporary city of tents and wooden buildings where the raw material of American manhood was being shaped into military units capable of matching the battle-hardened armies of Europe. The conditions were often crowded and sometimes difficult, and the training was intense, for there was a sense of urgency about the whole enterprise, a recognition that the war in France was consuming men at a terrible rate and that the American forces would need to be ready as quickly as possible. Hubble drilled with his men, learned the practical details of infantry tactics, studied the maps and the manuals, and prepared himself for whatever might come. It was during this period of training, rather than in the heat of combat, that Hubble sustained the only significant injury of his military service, a wound to his elbow caused by shrapnel during a training exercise. The details of the incident are not entirely clear from the historical record, but such accidents were not uncommon in the intensive preparation of troops for war, where live ammunition and explosives were sometimes used to simulate the conditions of actual battle, and young men who had never before handled such dangerous materials were learning their deadly properties under circumstances that could not perfectly replicate the chaos of the front lines. The injury to Hubble's elbow was serious enough to require medical attention, but it was not so severe as to prevent his continued service, and he recovered sufficiently to remain with his unit as it completed its preparations for deployment overseas. By the end of the war, Hubble had been promoted to the rank of major, a recognition of his capabilities as an officer and his steady performance throughout the months of training and preparation. The promotion was not an insignificant achievement for a man who had entered the army as a civilian with no prior military experience, and it reflected the judgment of his superiors that he possessed the qualities of leadership and competence that the rank implied. He would retain a certain attachment to this rank for many years afterward, and those who knew him in later life often noted that he preferred to be addressed as Major Hubble rather than Dr. Hubble, a preference that some attributed to affectation and others to a genuine pride in his military service, though perhaps it was simply that the title carried associations of command and authority that appealed to some aspect of his character. The 343rd Infantry Regiment finally received its orders for overseas deployment in September of 1918, and Hubble and his fellow soldiers embarked on the journey across the Atlantic that so many American troops had made before them, sailing toward the great conflict that had already consumed millions of lives and reshaped the map of Europe. The crossing itself was not without its hazards, for German submarines still prowled the Atlantic shipping lanes, and the troopships that carried the American expeditionary forces were prime targets for enemy attack, but Hubble's vessel made the passage safely, and the regiment arrived in France prepared to take its place in the line. But the timing of their arrival meant that they had come too late for significant combat, for the great German offensives of the spring and summer had been turned back, and the Allied counteroffensives of the autumn were pushing the exhausted German armies back toward their own borders. The armistice that would end the fighting was declared on the 11th of November, 1918, just weeks after the Black Hawk Division had arrived in France, and the guns fell silent along the Western Front before Hubble and his regiment could be committed to the kind of sustained combat that had defined the war for so many other units. This was, of course, a matter of profound relief for the men involved, for the trenches of France had proven to be a slaughterhouse of unprecedented scale, and to have avoided that particular horror was no small blessing. But it also meant that Hubble's military service, for all its duration and its demands, had not included the defining experience of battle that marked so many of his contemporaries. Instead of combat, Hubble and the American Expeditionary Forces found themselves engaged in occupation duties in the aftermath of the armistice, helping to maintain order and administer the terms of the ceasefire in the chaotic weeks and months that followed the end of hostilities. This was work of a different character than what they had trained for, requiring patience and diplomacy as much as military discipline, and it brought Hubble into contact with a Europe that was exhausted and transformed by 4 years of unprecedented destruction. The old certainties had been swept away, empires had crumbled, and millions of people were struggling to rebuild their lives amid the wreckage of a conflict that had seemed, at times, as though it might never end. It was a sobering experience for any young man, and it must have given Hubble much to reflect upon during the long months of waiting before he could return home and resume the scientific career that had been interrupted by his decision to serve. The process of demobilization was gradual and sometimes frustrating, for the army had to manage the return of millions of men to civilian life, and the logistics of this vast undertaking meant that many soldiers spent months in Europe or in stateside camps waiting for their discharge papers. Hubble's mustering out finally came in San Francisco in August of 1919, more than 2 years after he had sent that brief telegram to George Ellery Hale declining the position at Mount Wilson. He had been a soldier for the better part of his late 20s, had risen to the rank of major, had crossed an ocean and witnessed the aftermath of the greatest war in human history, and now, at last, he was free to return to the work that had first drawn him to the night sky and the faint nebulae that dwelt there. He wasted little time in doing so, traveling almost immediately from San Francisco to Pasadena, where Mount Wilson Observatory and George Ellery Hale awaited his arrival. The invitation that he had declined 2 years before had not been withdrawn, for Hale had recognized in Hubble a talent that was worth waiting for, and the position that had been offered in 1917 was still available in 1919. Hubble arrived at the observatory still in his military uniform, according to some accounts, a detail that speaks to the haste with which he made the journey and perhaps also to a certain pride in his service and his rank, and he presented himself to Hale ready to begin the work that would occupy him for the rest of his life. The military bearing that he had acquired during his time in the army never entirely left him, and those who worked with him in the years that followed often remarked upon his erect posture, his precise manner of speaking, and his air of quiet authority. He continued to prefer being addressed as Major Hubble for many years, even as his scientific accomplishments accumulated and his reputation as an astronomer grew, and this preference became one of the small idiosyncrasies that defined his public persona, along with the pipe he often smoked and the tweed jackets he favored and the faint trace of an English accent that lingered from his Rhodes Scholar days at Oxford. Some found these affectations pretentious, while others simply accepted them as the harmless peculiarities of a man whose mind was occupied with matters far larger than questions of personal style, and in any case, such considerations mattered little compared to the discoveries that lay ahead. The war years had been an interruption, certainly, but perhaps not an entirely unproductive one, for they had given Hubble experiences and perspectives that he might not otherwise have acquired, and they had allowed the new 100-inch telescope at Mount Wilson to be completed and made ready for the observations that would transform our understanding of the universe. When Hubble finally took his place at that great instrument and turned it toward the nebulae that had been the subject of his doctoral dissertation, he was not quite the same man who had left Yerkes Observatory in 1917, but he was ready, and the cosmos was waiting. In the autumn of 1919, Edwin Hubble made his way to the San Gabriel Mountains of Southern California, where the Mount Wilson Observatory stood high above the haze and city lights of Los Angeles, and where the clear mountain air offered some of the finest astronomical seeing conditions in the world. He arrived in September of that year, having recently returned from military service in Europe, and he came to take up a staff position under the direction of George Ellery Hale, the visionary astronomer who had founded the observatory and who had spent years securing the funding and engineering expertise necessary to build what was then the largest telescope ever constructed. Hale had a talent for persuading wealthy benefactors to support astronomical research, and his greatest achievement at Mount Wilson was the completion of the 100-inch Hooker telescope, named for the Los Angeles businessman John D. Hooker, who had provided the initial funds for its enormous primary mirror. This instrument, with its mirror spanning just over 2.5 meters in diameter, gathered more light than any telescope before it, and it allowed astronomers to peer deeper into the cosmos than had ever been possible, revealing faint objects that had remained invisible or indistinct to smaller instruments. The Hooker telescope was housed in a great white dome near the summit of Mount Wilson, at an elevation of some 1,800 meters above sea level, and the observatory campus spread across the mountain with various smaller domes and buildings connected by paths that wound through the pines and cedars. The telescope itself was a reflecting telescope, meaning that it used a curved mirror rather than a lens to collect and focus light, and this design allowed it to be built much larger than the refracting telescopes that had dominated astronomy in the 19th century. The primary mirror had been cast from plate glass and ground to exacting specifications over many years, and it weighed several tons, supported in a mounting that allowed it to track objects across the sky as the Earth rotated. Observers would spend long cold nights on the mountain, guiding the telescope and exposing photographic plates to capture the faint light of distant objects, and Edwin Hubble quickly adapted to this demanding routine, settling into a pattern of careful, methodical observation that would characterize his work for the next 2 decades. Hubble's primary interest lay in the spiral nebulae, those faint smudges of light that appeared throughout the sky and that had puzzled astronomers for generations. Through smaller telescopes, these objects showed a distinctive spiral structure, with luminous arms winding outward from a bright central core, and they were quite different in appearance from the diffuse gas clouds and star clusters that made up other types of nebulae. The great question of the time was whether these spiral nebulae were relatively small objects located within our own Milky Way galaxy, perhaps clouds of gas in the process of forming new solar systems, or whether they were instead vast collections of stars lying at immense distances beyond the Milky Way, each one a galaxy in its own right comparable in size and composition to our own stellar system. This question had been the subject of considerable debate, including a famous exchange in 1920 between the astronomers Harlow Shapley and Heber Curtis, who had presented opposing views on the nature and distance of the spiral nebulae before the National Academy of Sciences in Washington. Shapley argued that the Milky Way was enormously large and that the spiral nebulae were relatively nearby objects within it, while Curtis maintained that the spiral nebulae were independent systems, island universes as some called them, lying far beyond the boundaries of our galaxy. At the time of that debate, the observational evidence was insufficient to settle the matter decisively, and astronomers remained divided on the question. Hubble approached this problem with characteristic patience, undertaking a systematic photographic study of the spiral nebulae using the Hooker telescope's unparalleled light-gathering power. Night after night, when the weather permitted and the seeing conditions were favorable, he would expose glass photographic plates to the light of these distant objects, building up a collection of images that showed ever finer detail than previous observations had revealed. He examined these plates carefully, searching for individual stars within the nebulae, because if he could identify and study individual stars, he might be able to determine how far away those stars were, and therefore how far away the nebulae themselves must be. The key to measuring cosmic distances lay in finding stars of a known intrinsic brightness, because by comparing how bright a star appeared to be with how bright it actually was, one could calculate how far the light had traveled to reach the observer. This method depended on having reliable standard candles, as astronomers called them, stars whose true luminosity could be determined independently of their distance. The breakthrough came in October of 1923, when Hubble was examining photographic plates of the Great Spiral Nebula in the constellation Andromeda, known to astronomers as Messier 31 or simply M31. On the night of the 5th and 6th of October, he exposed a plate that, upon careful examination, revealed what he initially took to be a nova, a star that had suddenly flared in brightness. He marked it on the plate with the letter N, following standard practice. But as he compared this plate with earlier images and continued to monitor the object over subsequent nights, he realized that he was observing something far more valuable than an ordinary nova. The star was not simply fading after a single outburst, as novae do, but was instead varying in brightness in a regular, repeating pattern. He crossed out the letter N on his plate and wrote the letters VAR, indicating a variable star. What he had found was a Cepheid variable, a type of pulsating star that expands and contracts rhythmically, growing brighter and dimmer with a period that might range from a few days to several weeks. The significance of Cepheid variables for distance measurement had been established more than a decade earlier by the American astronomer Henrietta Swan Leavitt, who had studied thousands of variable stars in the Small Magellanic Cloud while working at the Harvard College Observatory. Leavitt discovered that there was a precise relationship between the period of a Cepheid's brightness variation and its intrinsic luminosity. The longer a Cepheid took to complete one cycle of brightening and dimming, the more luminous it actually was. This period luminosity relationship meant that by simply measuring how long a Cepheid took to vary, one could determine its true brightness, and by comparing that true brightness with its apparent brightness as seen from Earth, one could calculate its distance using the inverse square law of light. Leavitt's discovery was one of the most important contributions to observational astronomy in the early 20th century, though she received far less recognition during her lifetime than her work deserved, and she had died in 1921. Just 2 years before Hubble identified the Cepheid in Andromeda that would prove so consequential. Hubble continued his observations through the autumn and winter, identifying additional Cepheid variables in the Andromeda Nebula and carefully measuring their periods and apparent magnitudes. Using Leavitt's period luminosity relationship, he calculated the distances to these stars, and the results were striking. The Cepheids in Andromeda appeared to lie at a distance of approximately 900,000 light-years from Earth, a figure so large that it placed the Andromeda Nebula far beyond any plausible boundary of the Milky Way galaxy, which even the most generous estimates of the time placed at no more than 300,000 light-years in diameter. If the Cepheids were truly at such a distance, then the Andromeda Nebula could not possibly be a cloud of gas or a minor appendage of our own galaxy. It had to be an independent stellar system, a galaxy in its own right, containing billions of stars and spanning a vast region of space comparable to the Milky Way itself. Hubble's calculated distance of 900,000 light-years was, as later measurements would show, an underestimate. The modern accepted distance to the Andromeda galaxy is approximately 2.5 million light-years, and the discrepancy arose from several factors that were not well understood at the time, including the existence of different populations of Cepheid variables with slightly different period luminosity relationships, and errors in the calibration of the distance scale. But even Hubble's lower figure was sufficient to establish the essential point, that the spiral nebulae were extragalactic objects lying at distances far greater than anything within the Milky Way, and that the universe was therefore vastly larger than most astronomers had previously imagined. Hubble announced his findings at the 33rd meeting of the American Astronomical Society, held in Washington, D.C., on the 1st of January, 1925. His paper, presenting the evidence for Cepheid variables in M31 and the distance calculations derived from them, effectively settled the debate that had occupied astronomers for years. The spiral nebulae were indeed island universes, independent galaxies scattered throughout a cosmos of previously unimagined scale. Harlow Shapley, who had argued against this conclusion just a few years earlier, reportedly received word of Hubble's results before the official presentation and acknowledged that the evidence was compelling. The so-called Great Debate was over, not with a dramatic confrontation, but with the quiet accumulation of observational evidence carefully gathered and methodically analyzed, as is so often the way in science. In the years following this discovery, Hubble turned his attention to the systematic classification and cataloging of the galaxies that were now known to populate the universe. In 1926, he published a morphological classification scheme that organized galaxies according to their visual appearance, grouping them into several broad categories based on their shapes as seen in telescopic images. Elliptical galaxies appeared as smooth, featureless ovals of light, ranging from nearly spherical to highly elongated, and Hubble classified these with the letter E followed by a number indicating their degree of elongation. Spiral galaxies showed the characteristic winding arms that had first drawn attention to these objects, and Hubble divided them into two types, ordinary spirals and barred spirals, the latter distinguished by a bright bar of stars running through the central region from which the spiral arms emerged. Within each spiral type, he further distinguished between those with tightly wound arms and large central bulges, and those with more loosely wound arms and smaller bulges. Finally, he recognized a category of irregular galaxies, those that showed no clear elliptical or spiral structure and appeared chaotic or formless. This classification scheme is often represented in the form of a diagram resembling a tuning fork, with elliptical galaxies arranged along the handle and the two types of spirals branching off like the tines of the fork, and it remains in use today, though astronomers have since elaborated and refined it considerably. Hubble's work on galaxy classification was complemented by an ongoing collaboration with Milton Humason, a remarkable figure who had begun his career at Mount Wilson as a mule driver, hauling equipment and supplies up the mountain trails, and who had gradually worked his way into a position as a skilled observer and spectroscopist. Humason had an extraordinary talent for obtaining spectra of faint objects, patiently guiding the telescope for hours on end while the light of a distant galaxy slowly accumulated on a photographic plate. Working together, Hubble and Humason measured the spectra of dozens of galaxies, determining how much the light from each galaxy had been shifted toward the red end of the spectrum. This redshift, as it was called, indicated that the galaxies were moving away from us, their light stretched to longer wavelengths by their recession, much as the pitch of a siren drops as an ambulance speeds away. The faster a galaxy was receding, the greater its redshift would be. As Hubble analyzed the accumulating data, a pattern emerged. The more distant a galaxy was, the greater its redshift, and therefore the faster it appeared to be moving away. This was not a random distribution of velocities, but a systematic relationship, a proportionality between distance and recession speed that held across all the galaxies for which measurements were available. In 1929, Hubble published a paper presenting this relationship, which came to be known as Hubble's law. The law stated that the velocity of a galaxy's recession was directly proportional to its distance, with a constant of proportionality that became known as the Hubble constant. The implications of this finding were profound, for if all galaxies were receding from us with velocities proportional to their distances, then the universe as a whole must be expanding, with space itself stretching and carrying the galaxies along with it like raisins in a rising loaf of bread. It should be noted, in the interest of historical completeness, that the Belgian astronomer and Catholic priest Georges Lemaitre had arrived at similar conclusions 2 years earlier, publishing a paper in 1927 that derived the expansion of the universe from Einstein's equations of general relativity and that included an estimate of the rate of expansion based on the observational data then available. Lemaitre's work appeared in a relatively obscure French-language journal and received little attention at the time, and it was Hubble's 1929 paper, with its more extensive observational foundation, that brought the concept of the expanding universe to the attention of the broader scientific community. Lemaitre's contributions have since been more widely recognized, and some have suggested that the velocity-distance relationship should properly be called the Hubble-Lemaitre law, a naming that the International Astronomical Union formally adopted in 2018. And so, by the end of the 1920s, the picture of the cosmos had been transformed almost beyond recognition. The universe was now known to contain not merely the stars of the Milky Way, but countless other galaxies, each containing billions of stars of their own, scattered across distances of millions of light-years and receding from one another as space itself expanded. Edwin Hubble, working patiently at the eyepiece of the Great Hooker telescope on the dark and quiet summit of Mount Wilson, had played a central role in this transformation, and the decade that followed would bring further discoveries, further refinements, and further glimpses into the vast and ancient cosmos that surrounds us. On the 26th of February, 1924, in the pleasant city of Pasadena, California, Edwin Hubble married Grace Berkeleib in a quiet ceremony that would mark the beginning of a partnership lasting the remainder of his life. Grace was 34 years old at the time, and Edwin was 34 as well, both of them entering this union with a certain maturity and clarity of purpose that would shape the decades ahead. The wedding took place during a period of tremendous professional momentum for Hubble, who had only recently made the observations that would establish the true nature of the spiral nebulae, and one might imagine that the personal happiness of marriage and the intellectual satisfaction of scientific breakthrough mingled together during those early months of 1924 in a particularly gentle and sustaining way. Grace Burke had been born into comfortable circumstances and had received her education at Stanford University, where she developed the refined sensibilities and cultural interests that would characterize her throughout her adult life. She was a woman of considerable sophistication, possessed of social graces that had been carefully cultivated and a genuine appreciation for literature, art, and intellectual conversation. Before meeting Edwin Hubble, she had been married to Earl Leib, a geologist whose death had left her a widow, and this earlier experience of marriage and loss had perhaps given her a certain depth of understanding about the nature of companionship and the importance of building a life together with intention and care. When she met Edwin Hubble, she encountered a man whose ambitions matched her own in their scope, though his were directed toward the cosmos while hers were oriented more toward the cultivation of a distinguished social existence. The Hubbles established their home on Woodstock Road in San Marino, a gracious residence that reflected their aspirations and their growing prominence in the social world of Pasadena and its surroundings. The house was comfortable without being ostentatious, situated in a neighborhood of quiet elegance where the landscaping was always well tended and the neighbors were invariably respectable. Grace took charge of creating an atmosphere of cultivated refinement within their home, filling it with books and artwork and the pleasant accoutrements of an educated household, while Edwin provided the intellectual distinction that made their address a desirable one for dinner invitations and social gatherings. They would live in this house for many years, and it became a kind of salon where scientists and artists and writers might find themselves seated at the same table, discussing matters both cosmic and earthly over carefully prepared meals. It is worth noting, in the gentle manner appropriate to such personal details, that Edwin and Grace Hubble never had children together. The reasons for this remain private, as such matters ought to remain, and the historical record does not require us to speculate about decisions that belong entirely to the two people who made them. What we can observe is that the absence of children allowed the Hubbles to direct their considerable energies toward their respective pursuits, with Grace focusing on their social position and Edwin devoting himself entirely to his astronomical work, and that their partnership seemed to flourish within the particular shape they gave it. They were companions to one another, traveling together, entertaining together, and building a life that suited their shared temperaments and ambitions. Grace Hubble was, by all accounts, socially ambitious in the best sense of that phrase, meaning that she understood the importance of connections and relationships and worked diligently to cultivate them. She recognized that her husband's scientific achievements, however profound they might be, would benefit from being situated within a broader context of cultural prominence, and she set about ensuring that Edwin Hubble the astronomer would also be known as Edwin Hubble the distinguished gentleman, the fascinating dinner companion, the man whose company was sought by the most interesting people of his era. In this endeavor she was remarkably successful, and the Hubble's social circle came to include an impressive array of celebrities, artists, and cultural figures whose names remain recognizable even now. Among their friends and acquaintances one could count Aldous Huxley, the English writer whose novels explored the strange territories of human consciousness and whose conversation ranged across philosophy, science, and mysticism with equal facility. Huxley found in Hubble a man who could speak with authority about the physical universe while maintaining an appreciation for the humanistic concerns that occupied the writer's own imagination, and the two developed a friendship that brought together the astronomical and the literary in pleasant ways. Charlie Chaplin, the beloved film comedian and director whose work had made him one of the most famous people in the world, was another figure who moved within the Hubble's orbit, and one can imagine the curious juxtaposition of the man who made millions laugh and the man who measured the distances to galaxies, seated together in some Pasadena drawing room discussing matters of mutual interest. Helen Hayes, the acclaimed actress whose career on stage and screen would span many decades, was counted among the Hubble circle as well, as was William Randolph Hearst, the newspaper magnate whose influence on American media and politics was immense and whose hospitality at his castle in San Simeon was legendary. Anita Loos, the witty screenwriter and novelist whose work included the delightful satire of American society found in her book about a young woman named Lorelei Lee, was another friend, and her presence in the Hubble social world suggests the mixture of intellectual seriousness and cultural playfulness that characterized their entertaining. These friendships were not merely casual acquaintances but genuine connections, maintained over years and enriched by regular contact and shared experiences. Edwin Hubble himself contributed to this social success not only through his scientific distinction but through a carefully cultivated persona that set him apart from the typical image of the laboratory scientist or observatory astronomer. He had developed, over the years since his Rhodes scholarship at Oxford, an effect that might be described as that of an English country gentleman, complete with certain mannerisms of speech and dress that evoked the leisured aristocracy of the British countryside rather than the practical directness of the American Midwest where he had actually been raised. This was not precisely an affectation in the negative sense, but rather a deliberate construction of identity that Hubble found congenial and that served him well in the social environments where he wished to move. He dressed carefully and well, favoring tweeds and other fabrics associated with country pursuits, and he spoke in a manner that suggested education and refinement without being precisely British, though there were hints of Oxford in his vowels that he did not discourage. His pipe became a familiar accessory, and his bearing was that of a man accustomed to being taken seriously in any company. Whether this persona represented a genuine aspect of his character that had found its natural expression or a more calculated performance designed to achieve certain effects is perhaps not a question that admits of a simple answer, and the truth likely lies somewhere in the comfortable middle ground where authenticity and aspiration meet. Among the pursuits that reinforced this cultivated image was fly fishing, a sport that Hubble took up with genuine enthusiasm and considerable skill. He fished in the streams and rivers of Colorado during summer holidays, wading into cold mountain waters with his rod and reel, casting his flies with the patience and precision that the sport demands. He also traveled to England for fishing expeditions, returning to the country where he had spent his Oxford years and enjoying the particular pleasures of English rivers and the traditions that surrounded them. There is something fitting about an astronomer who spent his professional nights measuring the distances to objects millions of light-years away, finding his recreation in the intimate, careful attention required to present a tiny artificial fly to a wary trout in a clear stream, and Hubble seems to have found genuine refreshment in this contrast. The recognition of Hubble's scientific achievements during this period came in a steady accumulation of honors and awards that marked his growing stature within the astronomical community and the broader scientific world. In 1927, he was elected to the National Academy of Sciences, an honor that represented the acknowledgement of his peers that his contributions to astronomy placed him among the most distinguished scientists in the United States. Election to the Academy was not given lightly, and for an astronomer still in his late 30s to receive this recognition spoke to the profound impact his work on the nebulae and the expanding universe had already achieved. Further honors followed in the years that came after. In 1934, Hubble received the Barnard Medal for Meritorious Service to Science, an award given by Columbia University that recognized exceptional scientific achievement. This medal, named after the astronomer Edward Emerson Barnard, was particularly appropriate for an astronomer of Hubble's caliber, and its presentation added another distinction to his growing collection. Then, in 1938, he was awarded the Bruce Medal by the Astronomical Society of the Pacific, one of the most prestigious honors in the field of astronomy, given in recognition of a lifetime of outstanding research. The Bruce Medal had been awarded to many of the greatest astronomers of the previous decades, and Hubble's receipt of it confirmed his place among the luminaries of his discipline. Between these awards, in the years 1934 and 1935, Hubble traveled to England to deliver a series of lectures at Oxford University in his capacity as the Rhodes Memorial Lecturer. This appointment brought him back to the institution where he had studied as a young man, now returning not as a student but as a figure of international scientific prominence whose ideas had transformed the understanding of the universe. The Rhodes lectures allowed him to present his cosmological work to distinguished audiences, to engage with British astronomers and scientists, and to enjoy once again the atmosphere of Oxford that he had found so congenial in his youth. These lectures represented a kind of triumph, the young Rhodes scholar returning as an established master of his field, and one imagines that Hubble found considerable satisfaction in the symmetry of this experience. The lectures he delivered during this period, along with his desire to communicate his findings to audiences beyond the professional astronomical community, eventually took form in a book published in 1936 under the title The Realm of the Nebulae. This volume represented Hubble's effort to summarize his cosmological work for general readers, to explain in accessible language the discoveries that had occupied his professional life and the picture of the universe that had emerged from them. The book covered the classification of nebulae, the evidence for their extragalactic nature, the relationship between distance and velocity that had become known as Hubble's law, and the implications of these findings for our understanding of cosmic structure and evolution. The Realm of the Nebulae was written with care and clarity, reflecting Hubble's belief that the findings of science belonged not only to specialists but to all curious minds willing to engage with them. The book found an appreciative audience among educated readers who wished to understand the new cosmology without necessarily mastering the technical details of spectroscopy and photometry, and it helped to establish Hubble's reputation as not merely a researcher but a communicator of scientific ideas. The volume remained influential for many years, serving as an introduction to extragalactic astronomy for students and general readers alike, and its publication marked a significant moment in the popularization of the new understanding of the universe that Hubble had done so much to create. Throughout this period of social success, professional recognition, and public communication, there ran a thread of contention that deserves mention, though we need not dwell upon it with any spirit of drama or conflict. Hubble's relationship with Harlow Shapley, the astronomer who had moved from Mount Wilson to become director of the Harvard College Observatory, remained difficult and at times openly antagonistic. The two men had been on opposite sides of the great debate about the nature of the spiral nebulae, with Shapley arguing that the Milky Way encompassed essentially the entire universe and Hubble providing the evidence that proved otherwise. Shapley had been wrong on this fundamental question, and though he was a capable and accomplished astronomer in his own right, there seemed to be a residue of resentment that colored his interactions with Hubble in the years that followed. The rivalry between them was felt within the astronomical community, where it created certain awkwardnesses and required careful navigation by those who wished to maintain cordial relations with both men. Hubble, secure in his achievements and his honors, could afford to view Shapley's antagonism with a degree of equanimity, though he was not above responding to provocations when they arose. Shapley, for his part, seemed to feel that Hubble received more credit than he deserved, and that certain contributions from other astronomers were overlooked in the celebration of Hubble's discoveries. The precise merits of these positions need not concern us here, and we may simply note that scientific communities, like all human communities, contain their share of personal difficulties and professional jealousies, and that even the most elevated pursuits are conducted by people with the full range of human feelings and frailties. As the 1930s drew toward their troubled close, and the shadows of conflict lengthened across Europe once more, Edwin Hubble found himself increasingly drawn into matters far removed from the peaceful contemplation of distant galaxies. The man who had spent nearly 2 decades measuring the recession of nebulae and contemplating the architecture of the cosmos began to turn his attention earthward, toward the gathering storm that he believed would inevitably reach American shores. His advocacy for intervention in European affairs, which grew more pronounced as the decade waned, was shaped in no small part by the deep friendships he had cultivated with British scientists and intellectuals over many years, and by a genuine affection for British culture and institutions that had been part of his character since his time as a Rhodes Scholar at Oxford in his youth. This Anglophilia, as some might gently term it, was not merely an aesthetic preference for tea and tweed, though Hubble certainly appreciated such refinements. It was rather a profound intellectual and emotional connection to a world that had shaped his formative years, and to colleagues whose work he admired and whose company he treasured. When news reached him of the devastation wrought upon British cities by German bombing campaigns, and when letters from astronomical colleagues in England described the disruption of scientific work and the anxieties of daily life under the threat of invasion, Hubble felt these distant troubles as something close to personal concern. He spoke openly among his circles in Pasadena and Los Angeles about the necessity of American support for Britain, and he lent his voice to those who argued that neutrality was neither morally tenable nor strategically wise. The entry of the United States into the war following the attack on Pearl Harbor in December of 1941 transformed Hubble's advocacy into action of a more direct and consequential kind. Like many scientists of his generation, he felt a profound obligation to contribute his expertise to the national effort, and he was not content to remain at his telescope while younger men were called to serve in uniform. The particular nature of his contribution would draw upon skills and knowledge that might seem, at first consideration, somewhat removed from the measurement of galactic distances, but which in fact demonstrated the versatility of a well-trained scientific mind and the unexpected connections between seemingly disparate fields of inquiry. In 1942, Hubble accepted a position at the Aberdeen Proving Ground in Maryland, a vast military installation dedicated to the testing and development of weapons and ammunition. Here, among the flat coastal lands beside the Chesapeake Bay, he would serve as chief of ballistics and as director of the Supersonic Wind Tunnel Laboratory, positions of considerable responsibility that placed him at the center of crucial wartime research. The work he undertook there concerned external ballistics, which is the study of projectiles in flight after they have left the barrel of a gun or the tube of a launcher, and the mathematical and physical principles that govern their trajectories through the atmosphere toward their intended targets. The calculation of artillery shell trajectories is a matter of considerable complexity, requiring the careful consideration of numerous factors that influence the path of a projectile through the air. One must account for the initial velocity imparted by the propellant charge, the angle of elevation at which the weapon is aimed, the mass and shape of the projectile itself, and the resistance of the atmosphere through which it travels. This atmospheric resistance, or drag, varies with the speed of the projectile and with conditions of temperature, pressure, and humidity that may differ from one firing location to another, and from one day or even 1 hour to the next. At the very high speeds achieved by modern artillery shells, which may approach or exceed the speed of sound, the physics of drag becomes particularly intricate, involving the formation of shock waves and other phenomena that demand sophisticated theoretical treatment and careful experimental investigation. Hubble brought to this work the same methodical precision and mathematical facility that had characterized his astronomical research, and he found that the skills he had developed for analyzing the faint light of distant galaxies could be adapted to the rather different but equally demanding task of predicting where a shell would land when fired under specified conditions. The supersonic wind tunnel over which he presided was an instrument for studying the behavior of projectiles at speeds exceeding that of sound, allowing researchers to observe and measure the complex patterns of airflow and pressure that develop around objects moving at such velocities. The data gathered from these experiments informed the development of more accurate firing tables and more effective projectile designs, contributions that had real and immediate consequences for the conduct of military operations in distant theaters of war. Throughout his time at Aberdeen, Hubble held a position equivalent in status and authority to that of a colonel in the United States Army, though he remained a civilian scientist rather than a uniformed officer. This arrangement was common for senior researchers whose expertise was too valuable to be constrained by the formalities of military rank and structure, and it allowed Hubble to focus his energies on the technical work at hand while still commanding the respect and cooperation of military personnel at the proving ground. He applied himself to these duties with characteristic diligence, working long hours in an environment that was rather more hectic and demanding than the quiet nights he had spent at the eyepiece of the Hooker telescope on Mount Wilson. The recognition of his wartime contributions came in 1946, when Hubble was awarded the Legion of Merit, a decoration established during the war to honor exceptionally meritorious conduct in the performance of outstanding services. The citation acknowledged the value of his research in external ballistics and his leadership of the Wind Tunnel Laboratory, and it placed him in the company of many distinguished scientists whose work had helped to secure victory. Hubble accepted this honor with his customary reserve, neither boasting of his service nor diminishing its significance, but simply noting that he had done what was asked of him in a time of great national need. The years at Aberdeen necessarily interrupted Hubble's astronomical research in a direct and practical sense, as he could hardly observe the heavens while occupied with ballistics work on the opposite coast of the continent. Yet the interruption was not so complete as it might have been, for Hubble maintained a steady correspondence with his astronomical colleagues throughout the war years, keeping abreast of such developments as continued in the field and offering his thoughts on matters of interpretation and theory. The letters that passed between him and other astronomers during this period reveal a mind that remained engaged with questions of cosmology even while attending to more immediate and earthly concerns, and they show that Hubble never truly set aside his identity as an astronomer despite the uniform nature of his wartime work. Grace Hubble, for her part, devoted herself to war work of a different but equally valuable kind, contributing her energies to the American Red Cross during the conflict. The Red Cross performed innumerable services during the war years, from organizing blood drives and training nurses to providing comfort and assistance to servicemen and their families, and Grace found in this work an outlet for her own desire to contribute to the national effort. The war years were thus a time of separation and of shared purpose for the Hubbles, each serving in their own way while looking forward to the day when normal life might resume and Edwin might return to the work that defined his deepest aspirations. Even during the busiest periods of his ballistics research, Hubble did not entirely abandon his commitment to the future of American astronomy. He remained a vocal advocate for the completion of the 200-inch telescope then under construction at Palomar Mountain, a project that had been initiated before the war but whose progress had been slowed by the diversion of resources and personnel to military needs. Hubble understood that this great instrument, with its mirror more than twice the diameter of the Hooker telescope that had served him so well, would open new realms of observation and allow astronomers to probe deeper into space than ever before. He lobbied persistently for the continuation of work on the telescope during the war years, arguing that the project represented an investment in the scientific future of the nation that should not be sacrificed to short-term expediencies. His advocacy was not always welcomed by those who felt that every available resource should be directed toward the immediate prosecution of the war, but Hubble persisted in making the case that fundamental scientific research was itself a form of national strength, and that a nation capable of building the world's greatest telescope was a nation whose intellectual vitality would serve it well in peace as in war. The telescope project did continue, albeit at a reduced pace, and Hubble's voice was among those that helped to ensure its survival through the lean years of wartime austerity. The strains of wartime work took a toll on Hubble's health that would become increasingly apparent in the years that followed. The pressures of his responsibilities at Aberdeen, the long hours of demanding intellectual labor, and the general anxieties of a nation at war all contributed to a burden that manifested itself in physical symptoms he could not ignore. Hubble was a heavy smoker, as were many men of his generation, and the habit that had seemed merely a social convention in calmer times now combined with chronic stress to produce troubling signs of cardiovascular strain. His blood pressure, which had not been a matter of particular concern in his earlier years, began to rise to levels that would eventually require medical attention, though the full consequences of this development lay still in the future. The combination of heavy smoking and elevated blood pressure represented a pattern that medical science was only beginning to understand in its full implications, but which we now recognize as a significant risk factor for serious cardiovascular events. Hubble was not unaware of these warning signs, but like many men of his temperament and era, he was inclined to press forward with his work rather than to dwell upon matters of personal health that seemed to lie beyond his immediate control. The years of wartime service thus planted seeds of future difficulty even as they contributed to the success of the national cause. As the war in Europe drew toward its conclusion in the spring of 1945, and as victory over Japan followed in August of that year, Hubble began to contemplate his return to astronomical research with an eagerness that had only grown during his years of enforced absence from the field. The telescopes on Mount Wilson had continued to operate throughout the war, though with reduced staff and limited observing programs, and the Great Mirror for the Palomar telescope was nearing completion in the optical shops where it had been so carefully figured and polished. New instrumentation and new techniques promised to extend the reach of astronomical observation in ways that Hubble found deeply exciting, and he was impatient to apply these tools to the questions that had occupied his thoughts for so many years. The transition from wartime service to peacetime research was not instantaneous, as administrative matters and the general dislocation of the immediate post-war period required time to sort themselves out. But by 1945 and into 1946, Hubble was making his way back to the familiar grounds of Mount Wilson and the promising heights of Palomar, where the work of his lifetime awaited resumption. The man who returned to California was somewhat older than the one who had left, somewhat wearier in body if not in spirit, and bearing the invisible marks of years spent in service to purposes larger than his own scientific ambitions. Yet his fundamental dedication to the exploration of the universe remained undiminished, and he looked toward the new instruments and new opportunities that peacetime would bring with all the enthusiasm of a younger man embarking upon his first campaign of discovery. The Great Dome on Palomar Mountain was rising toward completion, and within it would soon rest the 200-inch Hale telescope, named for the visionary astronomer George Ellery Hale, whose persistence had brought both the Hooker and the Palomar instruments into being. Hubble knew that this telescope would allow him to see farther and more clearly than any instrument before it, and to address questions about the nature and extent of the universe that had tantalized him throughout his career. The wartime years had been an interruption, necessary and honorable, but an interruption nonetheless, and now the true work could resume in earnest, with new tools and renewed determination to understand the cosmos that stretched so magnificently above the quiet darkness of the California mountains. In the years following the end of the Second World War, the astronomical community turned its attention once more to the peaceful pursuit of understanding the heavens, and among the most anticipated developments of this period was the completion of a magnificent new telescope that had been under construction, with various interruptions, for nearly 2 decades on a remote mountain in Southern California. Palomar Mountain rises to an elevation of some 5,600 feet above sea level, situated roughly 90 miles southeast of the city of Los Angeles and about 45 miles northeast of San Diego, and its summit had been selected in the 1930s as the site for what would become, upon its completion, the largest and most powerful optical telescope ever constructed by human hands. The instrument at the heart of this observatory was a reflecting telescope with a primary mirror measuring 200 inches in diameter, which is to say a little over 5 meters across, and this mirror had been cast from a special low-expansion glass called Pyrex at the Corning Glassworks in New York State, then transported across the country and painstakingly ground and polished to achieve the precise curvature necessary for gathering and focusing the faint light of distant celestial objects. The telescope and its housing had been funded largely through a grant from the Rockefeller Foundation, and the project had been championed and overseen for many years by the astronomer George Ellery Hale, the same visionary figure who had previously been responsible for the establishment of the Yerkes Observatory with its great refractor and the Mount Wilson Observatory with its 60-inch and 100-inch reflecting telescopes. Hale had passed away in 1938, some 10 years before the Palomar telescope saw its first light, and so the instrument was named in his honor, becoming known officially as the Hale Telescope, a fitting memorial to a man who had done so much to advance the cause of large-aperture astronomy in the United States. The formal dedication of the Hale Telescope took place on the 3rd of June in 1948, a warm early summer day on the mountain, and the ceremony was attended by astronomers, dignitaries, university officials, and representatives of the various institutions that had contributed to this remarkable achievement. Edwin Hubble, who was by this time in his late 50s and had been working at Mount Wilson for more than 3 decades, was present at these dedication ceremonies, and he would soon be accorded a singular honor in recognition of his many contributions to the field of observational cosmology. When the telescope commenced its regular scientific operations, Hubble was granted the privilege of being the first astronomer to use the new instrument for research purposes, a distinction that acknowledged his status as perhaps the foremost observational astronomer of his generation. His first observing run at Palomar took place in January of 1949, during the cold, clear nights that are often favorable for astronomical work, and one can imagine the quiet satisfaction he must have felt as he guided this enormous instrument toward the familiar patches of sky he had studied for so many years, now able to peer deeper into the cosmos than had ever before been possible. The 200-inch mirror gathered approximately 4 times as much light as the 100-inch telescope at Mount Wilson, which meant that objects too faint to be detected or properly studied with the older instrument might now reveal themselves to patient observation and careful photographic work. Hubble continued his program of photographic surveys during this period, building upon the techniques he had refined over his long career and pushing ever deeper into the remote regions of space. The work proceeded in much the same methodical fashion it always had, with long exposure photographs taken through the telescope during the night, the developed plates examined and measured during the daytime hours, and the accumulated data gradually filling in the details of the cosmic map he had been constructing for decades. The greater light-gathering power of the Hale telescope allowed him to record galaxies at distances that had previously been beyond reach, and each new plate added incrementally to the census of these island universes scattered through the immensity of space. This was painstaking work, requiring patience and precision and a willingness to spend many hours in the cold darkness of the dome, but it was the kind of work at which Hubble excelled, and he pursued it with the same quiet determination that had characterized his earlier investigations. In the summer of 1949, however, Hubble's research activities were suddenly and seriously interrupted by a significant medical event. In July of that year, he suffered a heart attack, a myocardial infarction that required immediate medical attention and would necessitate a prolonged period of recovery before he could consider returning to any form of strenuous activity. Heart attacks were, in that era, treated with extended bed rest and careful limitation of physical exertion, and the weeks and months following his collapse were marked by enforced inactivity and the gradual, uncertain process of cardiac healing. His wife Grace devoted herself to his care during this difficult time, nursing him through the acute phase of his illness and subsequently enforcing with gentle but firm insistence the various restrictions and requirements laid down by his physicians. She monitored his diet, regulated his visitors, ensured that he rested when rest was prescribed, and generally managed the practical details of his convalescence with the same intelligence and capability she had brought to their partnership throughout their married life. The recovery was slow, as such recoveries necessarily are, and it required many months before Hubble was able to resume even a reduced schedule of professional activities. When he did eventually return to work, it was under conditions that acknowledged the limitations imposed by his altered state of health. His observing schedule at the telescope was significantly reduced from what it had been in earlier years, as the physical demands of a night spent in the unheated dome, climbing up and down the observing platform and enduring the cold mountain air, were now considered potentially harmful to his recovering cardiovascular system. Nevertheless, he continued to analyze the data he had already gathered, examining photographic plates, making measurements, and working through the calculations that would refine and extend his earlier results. The intellectual work of astronomy, the careful interpretation of observations and the drawing of conclusions from accumulated evidence, could be pursued in the warmth and comfort of an office, and Hubble remained engaged with these aspects of his research even as his time at the eyepiece diminished. During this same period, a significant development occurred that had important implications for Hubble's earlier work on the cosmic distance scale. The German-American astronomer Walter Bade, who had been working at Mount Wilson and who had made important observations during the war years when the blackout of Los Angeles reduced light pollution and improved observing conditions, had been conducting a careful study of the stars in nearby galaxies using the new Palomar telescope. Bade's investigations led him to recognize that there were in fact two distinct populations of Cepheid variable stars, which he designated as Population 1 and Population 2, and that these two populations had different intrinsic luminosities. The Cepheid variables that Hubble had used to establish distances to nearby galaxies belonged to a different population than the Cepheids that had been used to calibrate the period-luminosity relation in our own galaxy, and this meant that Hubble's distance calculations had been based on an incorrect assumption about the true brightness of his standard candles. When Bade worked through the implications of this discovery, he found that the distances to external galaxies were approximately twice as great as Hubble had calculated them to be, which in turn meant that the universe was roughly twice as large and twice as old as had previously been supposed. Bade announced this revision to the cosmic distance scale at a meeting of the International Astronomical Union held in Rome in September of 1952, and the news was received with considerable interest by the assembled astronomers. For Hubble, this revision meant that his earlier calculations of galactic distances and his derived value for the rate of cosmic expansion, the quantity that had come to be known as the Hubble constant, were in need of significant correction. One might have expected some defensiveness or reluctance on his part, given that this revision effectively doubled the size of the error in his published results, but by all accounts Hubble accepted Bade's findings with grace and scientific equanimity. He understood, as any good scientist must, that measurements are always provisional and subject to revision as techniques improve and new evidence comes to light, and he recognized that Bade's work represented genuine progress in the understanding of stellar populations and cosmic distances. The fundamental discovery that the universe is expanding, which remained the cornerstone of Hubble's scientific legacy, was not challenged by this revision but rather placed on a firmer and more accurate foundation. Hubble continued to work on refining the Hubble constant during his remaining years, seeking to improve the accuracy of the distance measurements and velocity determinations that entered into this crucial cosmological parameter. The value of this constant, which expresses the rate at which the universe is expanding and which can be used to estimate the age of the cosmos, remained uncertain and subject to ongoing investigation, but Hubble contributed what he could to its determination through his continued analysis of observational data. The work was technically demanding and required careful attention to the many sources of error that could affect astronomical measurements, and Hubble brought to this task the same meticulous approach that had characterized his research throughout his career. Throughout this period, Hubble also devoted considerable effort to advocating for astronomy to be recognized as eligible for the Nobel Prize. The Nobel Prize in Physics, which would be the natural category for honoring astronomical discoveries, had never been awarded for work in observational astronomy or cosmology, and the statutes of the Nobel Foundation appeared to exclude such work from consideration. Hubble believed that this represented an unjust oversight, that the discoveries made by astronomers about the nature and structure of the universe were every bit as significant as the discoveries in other branches of physics that had been honored with the prize, and he worked behind the scenes to build support for a change in the rules or their interpretation. He corresponded with colleagues, consulted with Nobel Committee members, and generally made the case that astronomy deserved recognition at the highest level of scientific honors. These efforts, however, did not bear fruit during his lifetime, and it was not until many years after his death that Nobel Prizes began to be awarded for astronomical discoveries with any regularity. Despite the constraints imposed by his heart condition, Hubble maintained an active social life during his final years, continuing to enjoy the company of friends and the pleasures of cultured society that had always been important to him. He and Grace remained connected to a circle of English expatriates living in Southern California, individuals who had settled in the region for various reasons and who shared with the Hubbles an appreciation for British culture, literature, and manners. These friendships provided a congenial social environment, opportunities for dinner parties and conversations, and the exchange of ideas on topics beyond the boundaries of astronomical research. Hubble had always valued good company and intelligent discourse, and these connections helped to sustain him during a period when his professional activities were necessarily curtailed. In the summer of 1953, Hubble was able to return to Palomar Observatory for what would prove to be his final observing runs with the Great Telescope. The mountain was beautiful in summer, with clear skies and mild temperatures, and the dome of the Hale telescope stood against the darkness like a monument to human curiosity about the cosmos. Hubble worked at the instrument as he had done so many times before, guiding the telescope toward selected targets, exposing photographic plates to the faint light of distant galaxies, and adding a few more data points to the vast accumulation of observations he had gathered over his long career. There was no way of knowing, of course, that these would be his last nights at the telescope, no premonition of the end that was approaching, and he simply carried on with the patient work of recording the universe, one photograph at a time, as he had been doing for more than 30 years. The pace was slower now, the schedule less demanding than in his younger days, but the essential character of the work remained unchanged. The photographic plates captured the light that had been traveling through space for millions of years, light that had left its source long before human beings existed on Earth and that was only now arriving at this mountain in California to fall upon a circle of silvered glass and be recorded for scientific study. Hubble had spent his professional life collecting this ancient light and deciphering its meaning, and in doing so he had transformed humanity's understanding of the universe we inhabit. The cosmos revealed by his work was incomprehensibly vast, populated by billions of galaxies receding from one another in an ongoing expansion that had begun in the unimaginably distant past, and this vision of cosmic immensity had become, thanks largely to his efforts, the accepted framework within which all subsequent cosmological research would be conducted. On the morning of September 28, 1953, Edwin Hubble was at his home in San Marino, California, a quiet residential community that lies in the shadow of the San Gabriel Mountains, not far from the observatories where he had spent so many nights gazing into the depths of space. The day began much like any other in the Hubble household, with Grace attending to domestic matters and Edwin preparing for what he expected to be another period of work at the telescope. He had been experiencing health difficulties for some years by this point, having suffered a significant heart attack in 1949 that had forced him to slow his pace and reconsider the intensity of his observational schedule, though he had returned to work at Mount Palomar after a period of recovery and had continued to make observations with the great 200-inch telescope that represented the culmination of so many years of technological development in American astronomy. That September morning, however, brought with it a cerebral thrombosis, which is to say a blood clot that formed within the vessels of his brain, interrupting the delicate flow of oxygen to neural tissue and causing the kind of catastrophic damage from which recovery is rarely possible. Edwin Hubble died that same day, at his San Marino home, at the age of 63, his life ending rather suddenly after a period in which he had seemed to be managing his cardiac condition reasonably well. The loss was felt keenly by Grace, who had been his companion and intellectual partner for more than 3 decades, and by his colleagues at the observatories and universities where his work had transformed the fundamental understanding of what the universe is and how it behaves. In accordance with wishes that Edwin had expressed during his lifetime, Grace made the decision that there would be no funeral service, no public gathering of mourners, no ceremony of the kind that might ordinarily mark the passing of a figure of such scientific importance. This was consistent with Hubble's personality, which had always contained elements of reserve and privacy despite his public prominence, and Grace honored his preferences in this matter as she had honored them throughout their marriage. What became of his physical remains has never been publicly disclosed, and it appears that he was cremated, with the disposition of his ashes remaining unknown to this day. There is no grave that one might visit, no headstone bearing his name and dates, no plot of earth where admirers of his work might leave flowers or stand in quiet contemplation of his achievements. This absence of a burial site has struck some as mysterious or even troubling, but it reflects nothing more than the private wishes of a man who preferred that attention be paid to his scientific contributions rather than to his mortal remains. Grace Hubble continued to live in San Marino after her husband's death, maintaining their home and preserving his papers and personal effects with careful attention to their historical and scientific value. She had been his constant supporter during the long nights of observation, the periods of intense calculation, the years of writing and revision that had produced his most important publications, and she understood perhaps better than anyone the significance of the documentary record he had left behind. Grace lived for another 27 years after Edwin's death, passing away in 1980 at a considerable age, having witnessed many of the subsequent developments in cosmology that built upon the foundations her husband had established. In her will, she bequeathed the Hubble estate to the San Marino community, ensuring that his memory would remain connected to the place where he had spent the final decades of his life, and she arranged for his scientific papers, notebooks, correspondence, and other materials to be deposited at the Huntington Library, which is located in San Marino and serves as one of the premier research institutions for the study of American history and culture. The Huntington Library became the custodian of an extraordinary archive, containing not only Hubble's published works and official correspondence but also the working notebooks in which he had recorded his observations, calculations, and preliminary thoughts as they developed over the years. These materials have proven invaluable to historians of science seeking to understand how Hubble's ideas evolved and how his landmark discoveries were actually made in the day-to-day practice of astronomical research. Among the treasures held at the Huntington are the notebooks from 1924, the very documents in which Hubble recorded the observations of Cepheid variable stars in the Andromeda Nebula that allowed him to determine its distance and thereby establish that it was a separate galaxy far beyond the boundaries of our own Milky Way. These notebooks were formally identified and announced to the scholarly community in 2008, more than 80 years after the observations they contained had transformed our understanding of the scale of the cosmos, and their discovery at the Huntington generated considerable interest among astronomers and historians alike. In the decades following Hubble's death, the fields of astronomy and cosmology continued to develop in ways that he might have found gratifying, as new instruments and new techniques allowed researchers to probe ever deeper into space and ever further back in time toward the origins of the universe itself. The expanding universe that Hubble had helped to document became the foundation for what is now called the Big Bang model of cosmic origins, a theoretical framework that describes how the universe began in an extremely hot and dense state approximately 13.8 billion years ago and has been expanding and cooling ever since. Hubble's observations of the relationship between galactic distances and recession velocities had provided crucial evidence for this expansion, evidence that subsequent generations of astronomers would refine and extend using instruments of increasing power and sophistication. The most famous of these instruments, and the one that has carried Hubble's name most prominently into the public consciousness of the late 20th and early 21st centuries, is the Hubble Space Telescope, which was launched by the National Aeronautics and Space Administration on April 24, 1990, aboard the Space Shuttle Discovery. The decision to name this orbiting observatory after Edwin Hubble was made by NASA officials who wished to honor his contributions to observational astronomy and to acknowledge the historical significance of his work in establishing the extragalactic nature of the spiral nebulae and the expansion of the universe. The Hubble Space Telescope represented a new approach to astronomical observation, one that placed a large reflecting telescope above the distorting effects of Earth's atmosphere, allowing it to capture images of unprecedented clarity and to observe wavelengths of light that are absorbed by atmospheric gases before they can reach ground-based instruments. The telescope experienced significant difficulties in its early months of operation, when it was discovered that its primary mirror had been ground to an incorrect shape, introducing a flaw that blurred its images and threatened to compromise its scientific mission. However, astronauts were able to install corrective optics during a servicing mission in 1993, and from that point forward the Hubble Space Telescope has functioned as one of the most productive and celebrated scientific instruments ever constructed. Its images of distant galaxies, nebulae, star-forming regions, and other celestial objects have become iconic representations of the beauty and strangeness of the cosmos, appearing in textbooks, magazines, museum exhibitions, and countless other contexts where they have shaped the public understanding of what the universe looks like when viewed with powerful instruments from above the atmospheric veil. The scientific achievements of the Hubble Space Telescope have been equally remarkable, including observations that have helped to refine estimates of the age of the universe, measurements that have contributed to the discovery of dark energy and the accelerating expansion of cosmic space, and detailed studies of the atmospheres of planets orbiting distant stars. In all of these endeavors, the telescope has carried forward the legacy of the man whose name it bears, extending the range of human vision into realms of space and time that Edwin Hubble himself could only have imagined during his nights at the Mount Wilson and Mount Palomar observatories. It is worth noting, in the spirit of careful historical accuracy that characterizes good scholarship, that the relationship between distance and recession velocity that is often called Hubble's law has been the subject of ongoing debate regarding the proper assignment of credit among the scientists who contributed to its discovery. In particular, the Belgian priest and physicist Georges Lemaitre published a paper in 1927, 2 years before Hubble's landmark publication, in which he derived a theoretical relationship between galactic distances and velocities based on solutions to Einstein's equations of general relativity, and in which he also presented observational data supporting this relationship. Lemaitre's paper appeared in a Belgian journal with limited circulation and was written in French, which may have contributed to its relative obscurity in the English-speaking astronomical community, and for many decades Hubble received primary credit for the discovery of cosmic expansion. In recent years, however, historians of science have called attention to Lemaitre's priority, and in 2018 the International Astronomical Union voted to recommend that the relationship be referred to as the Hubble-Lemaitre law, acknowledging the contributions of both scientists to this fundamental discovery. This renaming reflects a broader recognition that scientific discoveries often emerge from the work of multiple researchers and that the assignment of credit can be complicated by factors of language, publication venue, and the sociology of scientific communities. Another aspect of Hubble's legacy that deserves mention is the question of the Nobel Prize, which he never received despite his transformative contributions to our understanding of the cosmos. During Hubble's lifetime, the Nobel Prize in Physics was not typically awarded for work in observational astronomy, and there was no separate Nobel Prize for astronomy as such. Hubble and his supporters lobbied for the recognition of astronomical discoveries as eligible for the Physics Prize, and there is evidence that the Nobel Committee considered his work on multiple occasions, but no award was ever made. Hubble died in 1953 without having received this honor, and the Nobel Prize cannot be awarded posthumously, so the matter was effectively closed by his death. In subsequent decades, the Physics Prize has been awarded to astronomers and cosmologists with increasing frequency, recognizing achievements in areas such as the discovery of pulsars, the detection of cosmic microwave background radiation, and the measurement of the accelerating expansion of the universe, but these changes in the prize's scope came too late to benefit Edwin Hubble himself. What Hubble did achieve, beyond any prize or formal recognition, was the transformation of cosmology from a largely speculative and philosophical enterprise into a rigorous observational science grounded in careful measurement and empirical evidence. Before his work, questions about the nature and extent of the universe were matters for theoretical speculation and philosophical argument, with little prospect of definitive resolution through observation. After his work, these questions became amenable to scientific investigation, with hypotheses that could be tested against observational data and refined or rejected accordingly. This transformation represents one of the great intellectual achievements of the 20th century, comparable in its significance to the earlier revolutions associated with the work of Copernicus, Galileo, and Newton in establishing the modern understanding of the solar system and the laws of motion. In 2008, the United States Postal Service issued a commemorative stamp bearing Edwin Hubble's image, placing him among the select company of scientists, artists, statesmen, and other notable figures who have been honored in this way. The stamp depicted Hubble in a characteristic pose, his features rendered with the dignified reserve that marked his public persona, and it served to bring his name and accomplishments to the attention of a broad public audience that might not otherwise have encountered his work. Such honors, modest as they may seem in comparison to the cosmic scales with which Hubble concerned himself, represent the enduring recognition of his contributions by the society in which he lived and worked. At Mount Wilson Observatory, where Hubble conducted much of his most important research, There stands the Edwin Hubble Memorial, a tribute to the astronomer who spent so many nights peering through the 100-inch Hooker telescope at galaxies millions of light-years distant. The memorial provides a place where visitors to the observatory can learn about Hubble's life and work and can reflect on the significance of the discoveries made at this site in the mountains above Los Angeles. And on the surface of the Moon, far from Earth but visible on clear nights as a gray and pockmarked disk in our sky, there is a crater named Hubble in his honor, a small geological feature that will bear his name for as long as humans maintain their records and their interest in the history of science. These memorials, the telescope, the stamp, the crater, the papers preserved at the Huntington Library, all serve to keep alive the memory of a man who fundamentally changed our understanding of where we are in the universe and how that universe has evolved over billions of years. Edwin Hubble's legacy is written in the light of distant galaxies, in the measurements of cosmic expansion, and in the ongoing work of astronomers who continue to build upon the foundations he established during his years at the great telescopes of Southern California.